we can download we can write the IS specification name and we can download it for free. But sometimes if it is ISO specification, then it will ask for money. But anyway, I think we can get the specification details somewhere among ourselves. We can circulate wherever it is needed. Now coming to first the specification and relevant standard for CR product. The very basic one is the IS 513 Part 1 2016. It is cold reduced carbon steel sheet and strip Part 1. Because Part 2 also another grade is there. Part 1 is cold forming and drying purpose. And Part 2 is for high tensile and multi-phase steel. This is the very basic one for CR products. Then what has happened? Sometimes inquiry comes to us regarding the grades which are under ASTM A1008 slash A10018. And these grades I later on tell that equivalent to how it is IS 513. Then also this G3141 cold reduced carbon steel sheet and strips. Also inquiry sometimes come related to the grades of this G3141 corresponding equivalent grade 5.3 Part 1 or Part 2 we can also get it. And also there are the grades carbon steel tubes for machine structural purpose. This is mostly correspond to IS 5.3 Part 2. Then IS 11587 specification for structural weather resistant steel. In this specification, it covers both HR and CR. It is for weather resistance purpose. And for CR, we used to say earlier shell cut. Now, as per requirement of Government of India, we have to certify with the IS specification. Then the corresponding grade has been FE 490C is the grade for CR under CR products. Then coming to this IS 18316 2023 is very newly it has come this grade. This specification it has been newly designed. This is for both HR and CR grades intended for processing of semi or fully processed CRNO, CRGO electrical steel and CRNO cold rolled non-orientated steel which is produced in RSP, a silicon mill. The plant was also for CRGO, but somehow it was not stabilized, so we are producing CRNO over there. But also we can supply the CRNO semi-processed steel from our CRM3 mill. Here from Bokaro Steel Plant, earlier we had supplied. Now also just now I saw inquiry has come from Faridabad. So that is after producing this grade with low carbon, customer will take to their end and there they will decarb it, reduce the carbon, and they will later on use it for electrical purpose like electrical motor, fan, we used in fan and some sort of the transformer like that. So this grade basically we don't have yet certification of this. We have applied for certification, but we have taken quality extra and the CMO still till we certify with this grade, CMO will be providing certain in other name to customer. Now another is at the end IS 16162. This is for dimensional requirement. So now coming to cold rolled steel for general purpose. We all know CMO people are much aware that it is coming under consumer goods, home appliance, furniture, computer cabinets, etc. Other application we are using aerospace, civil, pipe and tubes, refrigeration tubes, beer seals, oil filters, fire extinguishers, so many things where electrical fixtures also. White goods are obviously covered there on home appliance it is covering. Then automotive auxiliary parts, bus, truck, body, many things. This CR products general purpose it is being used. Now coming to first the specification. That is, I have tabulated here 5.3 part 1 A1008 and ASTM A1008, then GIS 3141. In this case, you could see that first column, the grade name here hard symbolized as H, commercial, O, drawing, D, deep drawing, DD. These are the term used to be during 2000, I think 2006, 2006 and before 2008. After that, the name changed to like this: CR0, CR1, CR2, CR3, CR4, CR5. So the corresponding equivalent grade for CRGO, it is only the hard after tender mill, we without annealing, H rolled condition, it is being supplied. That so it is hard and called as CR0. CR1 is equivalent to CS type A, which is equivalent to SPCC, GIS 3141. CR2 is equivalent to CS type B, SPCD. CR3 DS type A and B at SPC in GS 3141, CR4 and DDS deep drying steel, and SPCF in GS 3141. So we basically our plant is able to produce up to CR4, not CR5, because there are, as I told, there are some limitation, also production limitation are there depending on the facilities available here. So to produce CR5 grades, we need to have very low carbon at the steel making stage. So that is for that we need to have RHOFB facilities. So those facilities are not available, so we are unable to go CR5, but CR4, though it is also critical to produce, still we are able, we can produce based on the orders. Recent we have an order, so that we are producing that CR4, but it is rarely this order comes. And coming to next one, you will be more familiar with this. And 513, again it is broadly divided: cold rolled, full hard CR0, and general purpose for CR1 to CR5. If you will see chemistry here, CR0 0.35 max, CR1 0.15, 0.12. A maximum limit it has been kept, but ideally this chemistry, if you will see, I was showing the which are the equivalent grade. In there, the chemistry range it will not match always, but based on the mechanical properties, I have tried to given that equivalent grades. So it is chemistry range. It is also immaterial, because often what happens, when specification is made, they try to keep as much as maximum limit as possible. So this way, yeah, if you will see IS 513, the carbon content maximum is very high relatively if you will compare to the other grades, other specification. But anyway, so this is the what I'm telling. What in the specification it is there. Our working range is completely different. We work in the different way regarding the actual mechanical properties. What is our requirement is there? What is customer requirement is there? What is the TDC requirement is there? Based on that, our chemistry design is different. So coming to this mechanical properties, you will see this is again maximum CR1 we are giving. The range is given here. The maximum is YS yield stress, the 280 MPa, tensile stress 410, and gauge length you see 80 mm and 50 mm depending on the requirement of the customer. But mostly it is gauge length 50 mm elongation. It is customer requirement. Usually it is there, and we measure our gauge length from our universal tensile test machine with gauge length 50 mm. So that way we provide properties. Here in CR3 grade, you will see there is another requirement: plastic strain ratio, R bar value, and tensile hardening component value, N value, tensile strain hardening component, N values. It is both this tensile strain hardening component value, it comes from the tensile test, but for plastic strain hardening ratio, there is another equipment in that it is being measured. And in all cases, the test direction is transverse. What is from the strip we take the test sample in the transverse direction. In contradictory to this, if we'll go to the other specification, I'll be showing there it is in a longitudinal direction. But in any way, whatever it is mentioned the IS specification, that way we are doing. Now the thing is, in the first case, CR1 case, though it is mentioned to give YS and UTS values, usually it is given on hardness test. It is not mandatory. Basically, I want to say it is not mandatory. So CR2 onward, this is mandatory. We need to give this mechanical properties test results. Coming to then, similarly, there is a mandatory of thickness if less than 0.6 mm, elongation values given the table shall be reduced by I think 4 mm. It is just missed that 4 unit. It was like that. So that way there are some requirement. Grade CRN may be supplied in any of the temper grades as mentioned in mechanical properties for temper other than the annealed and skin passed. May not apply and shall be as mutual agreement. Basically, the purpose is that here giving the tensile test only for the annealed condition, skin pass and annealed condition. Directly wherever we are giving after tandem mill, there is not required. But I'll come to later on. Sometimes customer demand, but we should be clear. If customer is demanding hardness for CR1 grade, hardness as well as tensile strength, that is not possible. I'll explain later on. And recently an inquiry had come like that way. So we have to educate the customer also. What is their requirement should be also sometimes. They get also confused. Okay. See, I'm just telling you, please remember here, CR1, 280, 410, like this. This is the maximum maximum YS and ETS it is asked. But if it is not skin passed and annealed, if only in the full hard condition or semi hard or half hard condition, this properties is not achievable. So we need to understand where is the issues. So I'll be coming later again.
Dr. Sahu, when somebody wants to ask a question, will you be able to?
Yeah, I wanted further clarification on R bar and N bar. Basically, R bar का application थोड़ा सा pictorially बताइए sir. वो R bar और N bar को थोड़ा समझना मुश्किल हुआ.
Can you introduce yourself, the person who is asking, and please you switch on your video also so that at least he is able to see who is speaking.
I'm good morning. I'm Mohanty from Pune.
Yes,
I had a question to further explain on N bar and R bar ratio, sir, and how it is applicable.
Okay, see, it is basically resistance for thinning. The R bar, it is says resistance for thinning. If we go to auto grade steels, CR4, CR5, auto grade steels, there sometimes customer demands. Tata Steel also getting R bar value around 2. Mean plastic strain ratio R bar value around 2. They are getting Tata Steel. So we can also, we are achieving also 1.8, 1.9. Sometimes also we are achieving. So thing is, we are achieving. This is basically main purpose is that there is a formula. You see. R1 plus R2 minus R3, divided by R0. There is a formula to calculate this. You need to calculate the, you need to test tensile test result along the longitudinal direction, along the transverse direction, along the 45-degree angle. And after that, after doing that, if you will calculate the R bar value from there, the tensile test result. So sorry, N value from the tensile test results, and you will calculate over there in the formula. You will find that R value. But we have a machine. We say there is a separate machine to calculate also without doing the 45-degree. This different degree tensile test. Directly, if you keep sample, it will give you also result. There is a separate formula, modular something. Its name is there. So that way we can get.
So
But
this is
your-
basically the displacement in that plastic zone. R bar value suggests what is the dislocation or displacement, that is the elongation in that zone.
No, it is very different. It is not, YS, UTS related.
Right, right.
YS, I'm not going much deeper because, scientific side, I am not going. But from the normal tensile, engineering stress strain curve, you cannot calculate over there. It is there only. It is showing what is the elongation, what is your toughness value, what is your YS value, what is your UTS value. There only you will get. For this calculating this, it is a very different one, and it is depends on texture also. From this you can correlate texture. Texture means 111 ND fibers. We tell it for that auto grades. For auto sector, it is more requirement is there.
In North Cell, more is better, sir. जितना
More is
ज़्यादा
better.
मिले,
More is better. Formability is better. More is better.
okay, sir.
Okay. Surface finish regarding, you see, the after cold rolling, tandem mill, then annealing, either batch annealing process or the continuous annealing process. Then we go for the skin pass. And after skin pass, the surface appearance also depends. Depending on the TDC and the requirement of the customer, there can be surface appearance can vary. It can be dull finish or matte finish, or it can be bright finish, depending on the roughness of the roll in the skin pass mill. So that way, if matte finish, dull in appearance, is very suitable for the decorative painting purpose. But in case of the bright finish, it is for metallic coating or electroplating sort of things. So in our CRM3, we basically produce dull finish or matte finish steel. And it can be the customer requirement sometimes how to quantify. To quantify it in terms of roughness. So we have also roughness tester. There we can measure the roughness, what is the roughness, which range it is coming. So if it is 0.5 to 0.2, so 2, then it is called as D, surface designation as D. If 0.5 to 1.2, it is C. Our roughness is coming around 1.2, 1.3 like that. So under D, designation could be D for that. So matte finish category it is coming. Okay, then strain aging also another factor. CMO, our marketing people also it's might be facing sometimes. What it happens? Strain aging is the interstitial element like carbon and nitrogen it come to the after if it keeps sometimes it is shift to the dislocation position. It come to the dislocation position. That way, what happens? Some stretchers mark it appears. Leader's lines it we tell, or that way ductility get deteriorated. For to avoid that, what should be done within 6 weeks? The material should be supplied to the customer. That is one thing. Then other thing is that the customer usually having facilities, so they can also achieve the freedom of this leader bend or stretcher strains sort of things when they will be straightening effective roller leveling. Prior to their fabrication, the roller leveling usually they do it. So that way they will try to avoid that. But instead of 6 weeks, we can go up to 6 months also, where in case of the CR4, CR5 grade steels, there what happens? This carbon and nitrogen is being stabilized with the addition of the titanium sort of things. So if this interstitial element is stabilized, then we can hold for more period of this before fabrication. Okay. Next, coming to hardness, I was telling CR0 is cold rolled full hard, minimum hardness 85. But sometimes, as I was telling you, customer demands half hard or quarter hard. Sometimes they mention the hardness also, minimum hardness, it should be like this, maximum like should be this. And at the same time, they cannot demand that our YS and UTS should be like this. Because the table clearly mentioned over there, it is only for skin pass and annealed condition. Not this here, what I am showing you, it is not going to skin pass. Up to last annealed, a dead soft. Last one is only skin pass. Before that, other things, half hard, full hard, all those things, these are not skin passed, not also fully annealed. So the hardness we can maintain, but not this not that that same criteria we cannot give the YS and UTS should be this much. Okay, next coming to grade designation and chemistry, what I was telling you, as per ASTM A1008, there are different types of CS, type A, type B, type C, type DS. In bottom it is written commercial steel, CS for commercial steel, type A, B, C it is covered. DS is deep drying steel, DS type A and B, deep drying steel, DDS, extra deep drying steel, DDS. All those things you will see the last EDDS CR5, DDS CR4, then DS type B CR3, then CR2, like this will be equivalent grade already I had mentioned over there. So this is just for familiarity that we should not be blind that okay, so from where these grades are coming, customer is demanding, it is already there exists, though it is not CR IS 513, it is exists in other grades. So equivalent grade we can very well make it, no issue. Then mechanical properties also you will see it is also very much similar to the what I had mentioned earlier regarding IS 513. Okay, 513 part 1. This is all these are part 1. Part 2 I have not yet talked about. Then again GIS 3141. The grade was symbol of the grade SPCC commercial quality, SPCD drying quality, SPC deep drying quality, SPCF deep drying quality, non-aging, aging, non-aging is the same thing. Stretcher strength will not come. If it is non-aging, stretcher strength will not come. We can hold it up to 6 months. We can keep up to 6 months. Extra deep drying quality, non-aging. CR5, actually CR5, CR4 and here SPCG, this is extra deep drying quality and interstitial free also. Tata Steel interstitial free steel name, they regularly produce interstitial free and they do not, carbon is very less, 0.001. That level they go, 001 carbon. And there is no interstitial, titanium is added, interstitial is stabilized. So here in the though it is 0.02, practically it is less, very much less than 0.1. Okay, coming to mechanical properties, GIS 31, same thing. What I was showing you, it will compare, na? It will match. Some variation little bit you may get, otherwise almost it will match with this IS 513. Then dimensional feasibility, you will see what were the minimum thickness and maximum width. What in our CRM3 we have produced 0.6 mm minimum thickness with maximum 1300 mm. This is produced, and also if you see width, it will further narrow 1250. Then we can go in thickness 0.4 and 0.35 also it has been produced. But if width is 0.35 and 0.4, thickness is 0.35 or 0.4, 1300 is not produced so far because there is some limitation on load factor. I think future it may be explored with feasibilities. So far, this is the feasibility we have. And in case of GP, in case of CR also maximum thickness width, we have gone 2 mm with 1560 mm width, and for GP we have gone 2 mm with 1500 mm width, and for cell car, what I was saying, IS 11587 WR FE 490C, where 450 is the UTS, In that case, we have gone so far minimum thickness 1.6 mm with 1250 mm. So further exploration can be done, but there is a constraint of mill load, so that need to be very carefully need to be seen if requirement is there. Here the basic reason is that highly alloying cell core is highly alloying. So many alloying element present in case of cell core, so that is why below 1.6 been has not been explored so far. Okay, other things regarding dimensional tolerance as per IS. Dimensional tolerance later it will come. Here, what has happened in HR? If 2.57 HR, if it is produced, this CR can be produced 0.29 mm. If 2.6, CR can go 0.3. Like this, there is a conversion factor. If it is equal to number 10, 3 mm, it can go to 0.7 mm. And if it is 4.8 mm, it can go to 2 mm. So 2 mm we are producing. I was telling basically what should be the input material for cold reduction. What should the input material from the first strip mill? Here also some difficulties are there. If we produce high strength steel with thickness, low thickness, for example, if we will go to 0.6 mm CR, 0.6 mm CR, and our CR strength should be high, 450 MPa. 450 MPa, if UTS is there, it will not be feasible to produce, even though it can be feasible in CRM. The reason being, there is also difficulties in production in HSM. There is also mill load capacity, some limitation is there. Thinner gauge usually for Selma 350, IS 2062 350, BR 350 means YS 350, UTS 590. In that case, 2.9. Any question, please?
हाँ सर ये CRM3 में कितना किलो न्यूटन का मतलब कितना लोड दे सकते हैं? Why we cannot go beyond 4.8 रोलिंग? क्या वो मतलब कितना मिल कैपेसिटी, लोड कैपेसिटी कितना है मिल का, कितना किलो न्यूटन का है?
Now question is beyond 4.8 we can go. That is not the constant. I am telling thinner. In thinner section we cannot go.
Suppose we want 3 mm CR coil or say higher size thickness CR coil. For that we will be requiring feed size 4.8, more than 4.8. तो वो क्यों नहीं हो पा रहा? Why you are limit?
इसमें ये there should not be issue in this case, but I think Nilanshu must be there. Nilanshu, can you tell please? Nilanshu, are you there?
Nilanshu is supposed to join, but maybe his session is a little later.
Okay, I'm
So,
telling him the
he
reason.
can answer it later also, sir. If you feel
Okay,
that he's a better
later you
person
can
to
get
answer.
answer. And here there should not be beyond even 4.8. There should not be an issue. But you see, tell me, is it that customer need beyond CR material 2 mm above 2 mm they need?
Yes, sir. Yes, sir. Lot of material is required. In fact, one of our customer, BG Sirke, they are insisting. They are asking for 350 YS, of course, and they are predominantly they want 3 mm and above in CR grade.
Which region it is?
Sir, this is BG Sirke. They want 350 YS और उसका thickness 3 mm, 3.1, 3.2 इस तरीके से मांग रहे हैं. They are basically जो
okay, let me clarify. When we are having 4.8 mm, 4.8 mm, input material is 4.8 mm. We are getting 2 mm. Okay. So we will not go to 2 mm. We will make it 3 mm. No issue. If you need 3.5, we can also 3.5 can be produced. 1 second, could you please give me 1 second some important hello.
Mohanty ji, we
Just
can
give me
also
time.
the Nilanshu he was talking about will be taking the next session. So
no, I'll tell you.
He can tell.
I'll tell you. See, 4.8 mm we have input material. So if it is 2 mm we are giving, just imagine that will not give that much reduction. Suppose you are giving 30%, 40% reduction, we'll reduce reduction. We'll give you in the shear material, no issue.
It will comply to those elongation and all percent,
it should,
etc. Everything will come.
It should comply. It should comply. And the other reason is that I am telling that main constant is not that getting to roll 4.8 mm. Main constant is that thinner section load getting higher. And not only here, also HSM structural mill, hot strip mill also, there it is also load constant is there. So that way,
ठीक है सर, नो इशू सर, हम लोग बाद में बात करें. Okay.
For high strength, now I am coming to auto sector. IS 5.3 part 2 auto sector. In auto sector, high strength steel has very much requirement in Pune side, in north side also, Gurugram. We see Magnum Steel recently we had visited, and they are 410 LA, IS 410 LA. Earlier we had supplied, and Silver Bright recently, Pune we have supplied 410 LA. And these are the high strength steel LA. I think it is NSR product. I think it is a very good scope to supply in the market. So that way, always a customer can explore, our CMO can explore it to get the order as much as possible on this high strength. We are very much the capabilities to produce it, and we are producing, and some new grade recently after visiting Magnum Steel 370W, 440W, 470 LA, 470 LA. Here I have missed 470 LA. They have also given order. So we are going to produce it now. I'm coming to that. Here for Magnum Steel, you see there is GIS 3445. Their grade requirement was STKM 13A. We can customize 370W. We can certify in this grade. We can supply. And here minimum requirement is 370 MPa UTS and 215 MPa YS. This is matching with this, part one. This is the part one, but next one I will be showing you part two. This is you are able to see now this slide.
Yes.
Grade is 3445 13B, STKM 13B, and right side IS 513 part 2, ISC 440 LA. So here the chemistry, their chemistry was this. We have given our chemistry IS 513 part 2 like this, and we can very well produce this grade also. This is recently we have got order. Just we are going to produce this one. Then also this one also for same thing, Magnum Steel we have got 470 LA. So this is also we are going to produce this. Basically I mean to say that 513 part 2 here there are many high strength grades are available, and we can explore with auto sector where is the requirement, and we can see the equivalent grade what can be done with the RCL, with plant and CMO, with combinedly we can decide that which grade we can provide, and we customize it and we can provide it. The dimension.
Dr. Sahu, I have one question. What is Magnum Steel making with this grade of steel? What end product are they making?
The high strength auto sector, what they are doing, two-wheeler bike handle, and there are many things, under the seat for four-wheeler and for the two-wheeler under the seat. What we sit where we are sitting, the below that person also, and many other component they are producing from the two-wheeler, mostly for two-wheeler, and four-wheeler sector, as I told you, also some part they are making. Here the reason being why they need this for high strength steel, as you know, day by day, carbon emission factor, that we need to be it need to be taken care. For that, weight of the vehicle should be less. For to have a weight of the vehicle less, our strength of the thinner material should give the similar strength what it was giving the thicker material. So now that is why they are going to thinner material and the vehicle weight is getting reduced.
Thank you. Thank you.
If vehicle weight getting reduced, then mileage also will be good.
Okay. Thank you. Yeah, you
Okay,
can
this
carry on.
dimensional specification you will see.
सर 470 LA कितना थिकनेस में दिया है? कब तक कितना तक बना सकते हैं? 2 mm, 1.5.
I think 1.2 or something. I think they had given. I have to check it.
ठीक है, okay.
Sir,
Because we can have similar requirement.
Okay, please look into that and let us share with
जो
it.
410 तो आपको दे रहा है, 470 भी वो ले सकता है, ठीक है?
Yes, sir. हाँ, 2 mm होगा तो हम लोग दे सकते हैं. Okay, then dimensional tolerance. You will see dimensional plus minus 0.03 in the thickness. It depends on the different width. Corresponding to different width and corresponding to different thickness, dimensional tolerance varies. Though we try to give as close as possible, but this is the specification design. Though maximum plus minus it is given, in our case it comes much less than that. What is the specified limit? Much less than that it comes. And for width also, less than equal to 1200 is plus 3 minus 0. And if it is 1200 to 1500, plus 5 minus 0. And more than 1500 plus 6 minus 0. Now I think very soon I will complete it. I will not take much time. This is galvanized strip sheet. It is basically used roofing, cable tray, boxes, Teslas, automobile sector also some seats are being used nowadays. Bottom person and silos, purlins for higher GSM grades also are using nowadays. You will see relevant standard is IS 277-2018. If we then also European standard 10346/2009 and ASTM standard A653 it is coming. Then IS 18385. This is we are not this feasibility is not there. Hot dip galvanized steel sheet plate strip for automotive application. We have not explored this one, and moreover we do not have a galvanized facilities. And then finally the dimensional tolerance. Coming quickly, this IS 277-2008, this standard covers requirements plain galvanized steel sheets and strips and corrugated galvanized sheets. These galvanized steel sheets covered by this standard are intended to be used for purposes such as paneling, roofing application, whatever I told you right now. So then, if you will see chemical composition also, different grades chemistry is given here, maximum chemistry. So if you need to certify, then within this limit it must be there. GP, most of the cases we are producing GP, we are providing the GP ordinary grade now we are providing. But also we are providing, if you will see towards end of that, GP 350, GP 450, GP 550, GP 350, you know, YS is GP 350, YS is 350. So this is also in many cases we have supplied GP 350. In between, whatever it is required, that also we can produce based on the customer requirement. We are developing our state-of-the-art testing lab is being created in CRM3 welfare building. It is very soon it will be functional, and we shall be able to also provide whatever the customer demand, GP 250, GP 275, GP 300 also we can provide, and we can give test certification for that. So if we come to the mechanical properties, here it is there. To GP 250 YS, it corresponds to YS. 450, 350, 230, whatever it is GP, it is correspond to YS only. And elongation also it is given here. But sometimes a customer demand that higher side elongation. In that case, we need to also, if customer is not convinced that okay, our minimum specification as per IS 277 will be like this, and you will be definitely getting more than that. Minimum elongation it is means if customer demands suppose it is 18, customer is demanding 25% elongation. If we are able to convince the customer it is well and good, if not, then also we can think of it if we can give on that elongation, but we shall try to, it will be best interest that let them get convinced that okay, this is the IS specification and we have to get the material certified as per the IS specification, but our elongation will be higher side. Okay, then after that GSM, you know, GSM, it is coating thickness, gram per square meter. Coating thickness, it is basically what happens nowadays, if you start from bottom, 120 the normal grade, 120, 180, 200, 600. Previously, this is the I am showing you the specimen 2018. Previously, it was from 80 GSM onward it was there. Now, normally that it has been recommended that to increase the coating thickness to 120 mm. So it is starting from the 120 mm up to 600 mm. We have also 275 GSM. We have also up to 600 GSM also we have produced here. And the main thing is that zinc pileup should not be there. That is one thing. Second thing, white rust. White rust should not come. Acha, before that, let me say how it is being calculated. It is a average coating thickness, top and bottom. It is both take into account. Top is 600, bottom can be 300, top can be 300. So average can be 600. But minimum, in case of 600, minimum coatings single spot test should be 510. If it is 510, then also it is equivalent to GSM 600. GP 350, GSM 600. Complete specification of that grade will be, grade name will be, suppose customer is demanding 350 YS, that will be GP 350, then GSM 600 it will be. So now the question is, what happens just like in CR grades or HR grades, it is getting rusted and brown rust forms, similar to that in GP. Also, white rust forms. There should be the way this white rust should not form. And this is again related to corrosion things. Why galvanized sheet we are providing? This is a sacrificial anode. It works as sacrificial anode in comparison to the steel. The steel doesn't get corroded, but zinc get corroded and steel get saved. Again, to prevent the zinc, there is a technique how to prevent that coating. I'm coming. It will be discussed later. Okay, how to prevent it? Few things more. Let me discuss complete it. Here, though I was telling that nowadays it is the requirement is 120 GSM onward. Still, if customer is very adamant, very much sticking to his demand, you give me 80 GSM, 90 or 100. That also we can provide, no issue. Then, if other standard, if you see, they are providing like this S220. S220 means S220 means you have YS220. S250 GT means YS250.
Mohant, excuse me, Mohanty ji, you have a question. I saw you raising your hand.
Just sir, just मैं आपको clarify करना था. It was not CR, but they had asked for GP coil or GP seat in above 3 mm with YS तो 340 जैसा मैं बताया and 450 उनका ये था GSM था कोटिंग का. तो ये feasible होगा क्या सर? ऐसे तो आज तक हम लोग 3 mm तो जा ही नहीं पा रहे CR में. इसलिए I asked in the CR question itself. They want thicker gauge GP coil in this 450 GSM coating and 340 YS.
See, I think Paricha is here. He will be able to answer. But before that, let me give my understanding here with you. Two things here. First is that production, if it is possible, tandem mill, it can be produced. Require the strength and ductility, it can be achieved through our, the continuous galvanized line. We can also do that. But only thing that if thickness is higher, the strength will be higher. Thickness is higher and strength also higher. strength you are 350 you are telling, and
Yes.
thickness is also telling to
Higher.
3 mm. In that
Yes.
case, the if thinner is there, thickness is higher, so there is no issue. But is it thicker, then in that case, we need to, there is tension leveler is there for straightening or flatness. To achieve the required flatness, some uneven if it remains after HDGL hot dip process, it will pass through the tension leveler. There it could be possible that our the tension leveler, it may not be sufficient to achieve that much flatness, because as it is getting thicker, the strength, the material property, though YS UPS will remain same, but if you cross sectional area, if you see the total load will be, total requirement load will be higher. I don't know if
Okay,
it
got
is
it.
feasible, but we may explore. Still I am passing to Parichay. Please, Parichay, you are here, no? Parichay?
Let us wait for his session, sir.
Okay.
He will be able to answer. We'll take the question again. Yeah, you
Okay.
can continue with yours. Mohanty ji, we will your questions will be answered in the next session.
Okay, ma'am.
Okay, next, what I was telling, S350 means similar things you can see. It should not look, what I'm telling, no? Whether it is CMO or a plant or for RCL or anybody, if sometimes customer requirement is like this EN grade, it should not look something very different. Everybody should be familiar with that. And plus Z, plus ZA, plus ZA, all these things, it is the coating. We are only plus Z, or we are giving only zinc coating. Zinc and iron coating we are not giving. Zinc and aluminum coating we are not doing. Aluminum and zinc coating we are not doing. All these are it's not feasible. Only zinc coating is feasible. But we need to see AS250 this grade. What does it mean, and how it is equivalent to our IS277. And here also GSM, I was telling GSM 100, 120 onward, I was telling 120 to 600. Here coating thickness 100 to 600. This is only coating thickness. And here zinc coating masses minimum, maximum what it is showing here. Then surface treatment, I was
So
telling.
what is ZF?
ZF, zinc and iron. Okay. Now coating surface treatment, the way what I was telling, zinc, there could be the possibilities of white rust formation. To avoid that, the passivation is being done on the surface, the chemical passivation, other possibilities, oiling, chemical passivation and oiling, CO, thin organic coating. Without oiling and passivation also it is feasible. See what is happening all over in the world, they are positively doing chemical passivation, chromate coating. Nowadays also some organic setup coating also somewhere people are moving. TISCO also experimenting with some other set of things. We are doing chromate passivation, and after chromate passivation also sometimes TDC I have seen that they ask for oiling, which we do not have oiling facilities. It's there. I think we have, but we are not doing oiling. We are not doing, and why customer get worried? Because sometimes they do not get confidence that okay, even though it is passivation, there could be possibilities that my material may be get white rusted. So apprehension is there in the customer end. So in order to avoid that, now CMO need to see what other supplier, other Tata Steel or other supplier, how they are convincing the people. If this sort of apprehension is coming with customer or not, if at all it is coming, how they are comparing with the other suppliers like Tata Steel and Jindal, all those things, how they are supplying, how they are getting satisfied with them. If sometimes what happen, I have heard that Tata Steel and others supplier, they give guarantee with salt spread test. So our material will stand for this much hour for salt spread test. If at all that also if come to us, we can also able to fulfill that also. So that way we need to see the what is the query, what is the concern, what is the apprehension of the customer, and accordingly plant and RCL always there to address that. So with this, I am completing my presentation. Any question or anything?
Yeah, if participants have any question, they can ask now. Or Dr. Sahu, we after the next session, we have an interactive session for 30 minutes from 12 to 12:30. So we request you to be present so that we can take questions. Their ED marketing sir also will be joining at that time. So
Sure.
if it is possible, you please be connected
Sure.
so that you can take questions at that time.
Sure.
Thank you so much for such an informative session. We all got to learn a lot today. I request people to, if it is bandwidth is not a problem, please keep your videos on because at least we know whom we are speaking to. So yeah, that is so nice of you. We'll take a quick break of 15 minutes. It's 11:17 now. So let us meet at 11, say 35. Okay? And then we'll continue with the next session. Okay. And Dr. Sahu, I request you to be present for the question answer session later on, sir.
Oh, sure, sure.
Yeah. Okay. Thank you. Okay. Then we take a 15-minute break and we join here before 11:35. Thank you. Nilanshu and Pariche, you are connected?
Yes, ma'am. Ma'am, you are muted.
Nilanshu, you will be doing CR?
Yes, ma'am.
So we'll have yours first for 20 minutes and then Pariche's for 20 minutes. Okay?
Okay,
Okay,
ma'am.
ma'am.
Yeah. Okay. Then we let us connect back at say 11:30.
Yes,
Okay.
ma'am.
And you
Okay,
will be
ma'am.
sharing your presentations on your own, right?
Yes,
Uh,
yes.
You can check if you have the rights for sharing. Otherwise, we will ask Lopa ma'am to give you the rights. Because Gadadhar Sahu had a problem. Dr. Gadadhar Sahu could not share. So you can just test, sharing.
Ma'am, is our screen visible?
Yes, yes, it is visible. Fine.
Okay, ma'am. We have our
Okay,
rights.
okay. I said 35, so we'll wait till 35. Nankishore ji, where are you posted? I am seeing you. So I just wanted to know which location are you posted in? Good morning, Rati sir. Nice to see you.
Good morning, man. How are you doing?
All good.
I answer on behalf of Mr. Nankishore. He's posted in our regional office at Mumbai.
Okay. Sir,
Probably he
see,
did
I
not-
took your
Probably he
advice
did
and
not hear you.
I'm doing this before 15th of the month. Yes,
Good
yes,
idea,
so
ma'am.
that way I have been in marketing. I know after 20th, we are all so busy. Last month, due to puja, it all got a bit shifted. So hence on, I mean,
This is ideally
this
the
is the
best.
ideal. Huh?
Ideally
December
the best
also, I
time.
plan to do it maybe 11th or 12th of the month.
And again, not doing it on Monday is also a good idea.
Yes, sir, because plant faculty also does not agree for Monday.
Ah,
They have lots of meetings tied up, everyone, sir. So Monday is not the right time, Tuesday or Wednesday. And between
Sure.
11th to 15th, I would like to complete this.
that's a good idea. I think it smoothly hota rahega.
Ha, yes, yes. Any suggestions for which product we should take up next month, sir? We
I
have
think,
done PM
in
plant
fact,
ka via road hua hai.
truly, ma'am, when we sit back and realize, I think it is the people in CMO who are the only set of people who actually know about all the products that we make in Steel Authority. Otherwise, we have been at, say, various plant locations. People generally have an idea about the products rolled in that particular plant.
Mm-hmm.
So I think one product at a time, if we keep on adding or keep on, taking for each and every product, I think it makes sense. It's a good idea. Combination of long and flat in alternate method.
Yeah, हाँ, तो next time शायद TMT कर सकते हैं. Let us see. हाँ,
अच्छा है.
ठीक है.
TMT is again a
I'll
very
ask
big
Pankaj
basket
Mathur
for
sir also.
us. I
Normally,
think alternate.
ED marketing office, they give us the guideline on which product to take up. But as you said,
Yeah.
we combined GP and CR this time. Then it is becoming lengthy now. Because for GP and CR also from the rolling mill side also we have two different faculty because area of expertise is different. So it's 11:37. Lopa ma'am, are you there? Should we start? I think we'll go ahead, sir. We have around 38 participants. More will join. Welcome back. Let us move to the second session for today. Rolling challenges and quality issues. For this session, we have two faculties who will cover CR and GP separately. Each will take approximately 20 minutes. For CR, we have with us Shri Nilanshu Kumar, Senior Manager CRM3, Bokaro. Nilanshu has done his BTech in Metallurgical Engineering. He joined SAIL as MTT in 2013 and has been working in cold rolling mill since then. He is presently working as operations in charge of HRCC and PLTCM. Nilanshu has been involved in different performance improvement projects for PLTCM, which include increasing input yard capacity of PLTCM, optimization of process automation with the help of maintenance team. Recently, he has taken up energy optimization project this year, which is expected to save over 1.5 crores per year. His area of interest include cold rolling process optimization, digitalization, and ESG. I'll mention a few of his achievements, which he did not share initially. I had to really request him last night that thoda aur batao apne bare mein. He has won the Best Shift in Charge Award in 2019, NMD Award in 2021, Best Implemented Suggestion Award in 2024. Nilanshu also plays cricket for Bokaro cricket team. BSL cricket team. Welcome, Nilanshu. We'll start with your presentation. So you've already shared. Yeah, so over to you.
Thank you, ma'am. Good morning, everyone. I am Nilanshu Kumar, and I'll be talking about cold roll products of CRM3, in which I will basically deal with the CR route, and after me, my colleague Parichay will talk about galvanizing products. I hope my PPT is visible
Yes,
to you.
yes, it is visible.
The agenda of my presentation will be, I will be talking about basics of cold rolling and the CR route in CRM3, different processing units which we have at CRM3, our product mix, major quality issues which we face, some of the rolling defects and the countermeasures we take to overcome it, and some of the rolling challenges and constraints which we have at CRM3 in different sections. Now coming to types of rolling at BSL, we have hot rolling, which gives input to CRM3. Then we have cold rolling and we have a skin pass mill at CRM3. In hot rolling, we roll the slabs which we get from continuous casting shop or steel melting shop at a temperature around 1100 degrees Celsius. And it is done above the recrystallization temperature. That is why it is called hot rolling. And recrystallization temperature is, in basic terms, you can say it is 0.4 to 0.6 times the melting point of the metal. And then coming to the cold rolling, it is done below the recrystallization temperature. For us at CRM3, we do it at around less than 60 degrees Celsius. During cold rolling, work hardening takes place. I will talk about it further later. And then we have a skin pass mill, which gives, we have a light reduction there, in which 0.5 to 1% elongation is done. And it improves some mechanical properties as well as increases the surface roughness and improves the flatness of the strip. Now, what is cold rolling? Cold rolling is the process of rolling in which we plastically deform the steel and give a reduction to the thickness in with the help of steel rolls and hydraulic cylinders, and we have a electrical motors which facilitate us in achieving the reduction of our thickness of this hot rolled coils. Now, why cold rolling is done? To attain thinner gauges, we at CRM3, our rated capacity is 0.25 millimeter to 2 mm, and then it increases the surface reflectance of required for the white good products. It enhances material and mechanical properties. Then also it gives close dimensional tolerance which we are not able to achieve at hot strip mill. Now the moving ahead, the processes involved here, we get slabs from, we can see integrated steel plant have written, we get slabs from CCS or the continuous casting shop. Then it goes to the HSM hot strip mill where hot rolling is done. We get HR coil as input. We keep this coil for 3 days cooling time, and we roll it at around 60 degrees Celsius. We process when it is around 60 degrees Celsius. First we do pickling, then cold rolling, then annealing, then we have a skin passing, then a different route of SDGL where we give the zinc coating, and then the tension finishing of the coil is done by the packing, and tension, if required, tension leveling is done. These are the typical facilities. First we have get hot coils, then this is the pickling and tandem cold mill, that is called PLTCM. Then we have this batch annealing. Then we have another route is galvanizing. Then we have the skin passing mill. We have a don't have a recoiling line, but we have a tension leveler line. Now coming to the capacities, rated capacity of CRM3, it is rated for 1.2 million ton per year, and presently we are rolling it, producing around 0.7 to 8 million ton per year. We have 3 routes for processing the CR coil. The PLTCM, that is pickling line and tandem cold mill, is the mother unit. After that we have 3 routes. One we can we go to annealing, then SPM, then TLIL, then the packaging. The other route is, before going to annealing, we can do electrolytic cleaning as per the customer requirements. And the third route is the galvanizing route, which Parichay will talk about. Now, these are the different coils at different stages. The first is the HR coil, which CRM3 takes as the input. Then this is the then second photo is of CR coil, the reduced coil after PLTCM. Then we have the galvanized coil, GP coil. Then we have 2 types of packing. The one is the zinc galvanized sheet packing, and the other one is the resilient packing, which has stopped as for now due to customer complaints. Now coming to the processes at CRM3, first process is we do pickling of the HR coil. As we have oxide layer formation during the hot rolling, we remove it by making the coil pass through our different tanks, which contains hydraulic acid from 5 to 15%. at a temperature of 80 to 85 degrees Celsius. And after this, the oxide layer, which is not suitable for rolling, is removed. Then, then we have a side trimmer for close width tolerance. We have a side trimmer. We trim around 25 to 30 width from the HR coil. Say for 1280 from HR coil, we reduce the width to 1250, and our tolerance for it is plus 2 maximum. We can what we can closely achieve is plus 2 and in negative tolerance is 0. Then after pickling and side trimming, we go for cold rolling of the coil, in which we give around 50 to 85% of reduction. The HR coil is reduced from say, for example, we have a thickness of 3 HR coil, we reduce it to 0.7 or we have uh, 2 coil, we have reduced it to 0.25 the our product basket in terms of thickness is what we are at present producing is 0.3 to 2 the design capability is 0.25 to 2 What Mohanty sir was inquiring about, sir, design capacity is up to 2 only, so we cannot deviate up to 50% of the design capacity to 3 maybe we can try for 2.1 or 2.2 thickness. And for width, we have gone up to 1570 width. After cold rolling, the coil which we produce. Yes, ma'am.
Nilanshu, I just want to ask you, are other producers giving CR above 2
Yes, ma'am. Yes, ma'am. Tata Steel is what I know is giving up to 3
Okay, we are not making. Okay.
SW भी
Yeah.
दे रहा है.
Our design capacity, ma'am, 2 है.
I understand. तो इसीलिए हम नहीं दे पा रहे. Okay, thank you.
Now, after cold rolling, the coil which we get is not suitable for other formability and drawing applications. So annealing is again very important, in which the stress produced during the cold rolling is removed. The recrystallization of grain structure is there as we heat above the recrystallization temperature. After annealing, the material softens and we require another process of skin passing, which is very important again. These are two photographs of annealing section. One is on the left hand side is batch annealing, which we have at CRM3, and the second is the continuous annealing, which we are using this facility of continuous annealing of our existing or old CRM complex, in which we are giving through the DCR route. Now, and this is the different process of annealing, which process steps of annealing which we are doing at BAF, that is Bell Annealing Furnace. We load we stack the coil on the empty basis, then we have a furnace, and first we heat it to a defined temperature according to the different materials, and then we soak it, then we have a cooling process, then we unload the coils and give it to the skin passing mill. It takes around 96 hours for processing one coil. So one batch of coil, it takes around 96 hours for processing through BAF. Now, after BAF, before coming to skin passing mill, the other route which we have is electrolytic cleaning line, in which we clean the oil and iron fines produced during the cold rolling process at PLTCM. We clean the steel surface with the help of a electrochemical process using alkalis like NaOH and KOH, sodium hydroxide and potassium hydroxide. Then due to this process, the reflectance of our product increases many a times, and then the after annealing, we have this skin passing mill, in which, as I told earlier, it helps in improving the mechanical properties. It gives surface roughness, as we have a as we use rough rolls over there, and then we uh, we also improve the flatness as we have a shape meter roll over there, which helps in improving our flatness. Then this is the flow of skin. It is a one stand mill in four high. We have, as it is four rolls, we call it four high mill. We have a payoff reel in which the coil gets uncoiled, then it goes through to the mill of we give around 1.1% elongation, then it is called. Also, we after just after the stand, we have a electrostatic oiler in which acts as a rust preventive oil, and we give it in 100% of the coils. We do it in 100% of the coils. After in skin passing mill, if the flatness is not improved, again we can improve the flatness in tension leveler and inspection line. Also, a few customers ask, Bhel had asked for coils through TLIL. So we process those coils through TLIL, where again other flatness defects are removed. Then we have this hot dip galvanizing line, where we give zinc coating. Parichai will give elaborate description about this line. Then again we have a, coil packaging line, CPL, where we give 3-layered packaging. Then we have a stretch film. We have a stretch film wrapping with Coil Master. Also, we give protection to the eye with help of eye strapping. This is the photo of a packaged coil. Now coming to the product mix, what we are capable to produce over here is 0.25 to 2 mm. At present, commercially, we have not produced 0.25. We have only produced 2 to 3 coils of 0.25 on experimental basis. For width part, we have a capacity of 800 to 1560. The narrowest coil which we have produced 26 for bitumen grade coils, and we have gone up to 1570. The coil ID is 508 mm. Coil
Excuse
OD
me, could you repeat that part? What is the narrowest?
narrowest according to capacity is 800, but what we have processed, it is 876. have not got ordered below 876. 876 mm. And
Nilanshu, you also told that you have produced only 3 coils of 0.25. So is it because we don't get orders in that thickness?
yes, ma'am. We don't get. Also, it is the thinner we go, it is difficult for from the mill side. So, but we have produced 2.25 coils.
Okay. So we have the capability, but we are not doing it. Okay.
Yes, ma'am. 2.9 we are regularly producing.
Okay.
2.9 we are regularly producing for the galvanizing products.
So what is the minimum thickness that we can produce for GP coils?
Ma'am, for that also it is 0.3 it is there.
0.3. Okay, can we go below 0.3 in GP? Like 0.25 or 0.21?
Ma'am, HDGL line is designed for 0.3 minimum.
Okay, okay. Thank you.
The maximum coil weight is 31 tons. Width tolerance that we can give is ±2. Maximum we can go for 2 mm only. Not below that. If like one customer had demanded for 1 mm tolerance, so that much close tolerance is very difficult to produce over here. Then in thickness tolerance, we have our mill is very good in that. In terms of thickness tolerance, it is less than 20 microns. Tensile strength, according to design, is 680 megapascal maximum, and this yield stress is around 200 to 550. We have gone up to 440 for some products of high strength. Now the salient features of some CRM3 is the for ultra cleanliness we have a electrolytic cleaning line. Also hydrogen annealing, which we have at BAF, is helps in giving a brighter and cleaner surface, which was not possible in nitrogen annealing, which we had in our old CRM. Then we have a for rust prevention, we have electrostatic oiler at SPM, in which we give in 100% coils. Then we have tension leveling line for surfaces. Then we have this three had many complaints is now stopped. Now we have gone back to the galvanized sheet coatings packaging. Now coming to the diversions which we are facing at CRM3, majority of I have taken only the major 5 diversion. One is ridge, then we have the rusty, then we have roll marks and center buckling. Now coming to the major defect, I will talk about two, 3 major defects. One is ridge. So ridge, I will first show this photograph of ridge, which when I had an interaction with CMO people, we have they call it edge waviness. So this in ridge we have small pockets. In the third photograph you can see small pockets are formed. This is ridge, which is developed at the hot rolling stage, and it is not possible to eliminate in the cold rolling stage. Also in the coil also we you can see when if such type of coil is you will encounter such type of coil, you can see there is a bulge kind of thing in the side center wherever. In this coil you can see in the side of the coil you have a bulge over there. So basically, we have much of the diversion. Main diversion for CRM3 is ridge. Now, ridge is basically we have a this is the elaborate description of ridge, which is we have a increase in thickness in that part, and after coiling, this thickness get pronounced and we can see a bulge in the side of the rolling. The major causes for this to occur is hot unequal rolling pressure is may have been given at hot rolling. Also, improper cooling or is done at the hot rolling mill. Then when crown is not maintained, also when HSM produces coils and it goes for longer campaign length in between two roll changes, this can also account for ridge. As far as the remedial actions, what has been taken after modernization, HSM has tried to maintain the profile of the coil. Also, they have reduced the shorter campaign length on request of RCL. So we are hoping to get less amount of ridge in the coil after the recent modernization which HSM has gone up in April 2024. Then we have the second major defect which we are having in CRM3 is rusting. Rusting is a oxidation of the coil in basically due to the moisture contents over there, and moisture content can go through various mediums, like if at the starting from tandem mill, if the rolling oil or the emulsion goes to the metal surface and it is passed over to the annealing section, it also can be a cause for rusting. Then we have high atmospheric humidity, we have roof leakages at different places. CRM3 which is being taken care of by our CED department. We are hoping to improve on different causes of rusting. This is a coil which got rust due to holding time, prolonged holding time, and also due to the roof leakages. Now the remedies which we have taken already for we are doing now proper wiping of emulsion at tandem mill. Also, we have tried to reduce coil storage time between different processes, and also we are working on the before every rainy season there is a check for roof leakages in different section of CRM3, and it is being rectified. Some other defect which we are facing, which we face sometimes, you must have encountered also, is a serrated edge. This occurs due to bad trimming at PLTCM due to a bad shape. Though this is corrected in one or two coils.
Excuse me, sir.
Yes, yes, sir.
Sir, I am Nutan from Coimbatore.
Yes, sir.
Sir, regarding rusting in CR, our customers here complain that on CR coil, something is written with wet chalk, because of which
Yes.
it gets rusted. By the time the coil comes to Coimbatore, that portion is rusted.
Okay, okay, sir.
Because and they are requesting for avoiding writing with the wet chalk on the coil.
Okay, okay, sir.
So that part of the coil is wasted, and they always count one sheet as wasted.
Okay, okay, sir. I'll take care. I'll ask my
Yeah, you please note,
counterpart.
I think the material of that chalk is causing a problem, right, Nutan?
Yes, madam.
Okay. So, Nilanshu, you can look into it, please, in your department.
Yes, ma'am. Yes, ma'am.
Yeah.
Okay.
Okay. Please continue.
I've taken a note of it. Yes, ma'am.
Yeah.
Yeah,
Thank you.
thank you.
Continue.
Now, some other defects, which is this is on the photo on the left hand side is serrated edge, which is due to a poor trimming or bad trimming at PLTCM section. This has reduced in recent years, but still in some one or two coil it goes. We try to divert it at our SPM itself so that it does not go to the prime customers. Then we have one defect of this. This is a hole, or you can say due to during rolling, some part of roll is chipped off, or a metal pickup is there on the roll. Then this hole is produced in the coil. This also can be avoided by a regular inspection, which we are doing, but in one or two coils, like in not like inspection is not done in every coils at PLTCM. So this can be sometimes, but still we are trying to eliminate it. Now, coming to the major challenges and constraint which we are facing in CRM3 at different section. I'll start with laser welder with PLTCM, in which we have laser welder, which still has not been very reliable, but has improved manifold, and we have now, like before 2020 our production rate was uh, around 40,000 to 40,000 per month. Now we have gone up to 80,000 per month since last year. On an average, it is around 65,000 per month. So laser welder has improved, but still the for higher production, it has to be very reliable. As for I had visited Tata Steel, they are producing 100 coils in every shift, and one of the major reason is uh, quality of weld. They don't have to check; just they weld and they start the line. But we have to check the every weld so that it does not open a single weld opening. Then second. Second challenge for us in PLTCM is absence of shape meter roll, which is detrimental for a better shape. It was it was there in the design, but it due to spare issues and other issues, it has not been continued. Uh, we are in the procurement process is there for a different shape meter roll, which I don't know when it will take around maybe 1 to 2 years to get it installed. Then the next challenge for us is rolling of the thinner and narrow coils. Uh, they uh, they reduce the productivity of our rolling in all section. They reduce the productivity and it is
Excuse me, sir.
yes, sir.
So the shape meter has come, right?
Sir, I was talking about PLTCM, sir. Shape meter at SPM has come. So sir, mother unit is PLTCM, so major shape issue has to be resolved at PLTCM itself.
Okay.
At SPM, it is the additional facility to improve the shape. So major what shape is the coil gets has been decided at PLTCM itself. So at PLTCM also there was a shape meter roll. But
So that is not there now. That is absent now at PLTCM.
yes, sir. Yes, sir. Yes, sir. So,
Okay.
but still, we don't have much complaints from the customer end, I guess, for shape.
After this shape meter has been installed at SPM, there were not many complaints, sir.
Yes, sir.
Okay, okay.
Okay, thank you. Continue.
Then we have the other constraint I was talking about, the thinner coils. Parichya will give a elaborate uh, analysis about thinner coils and how this reduces the productivity of our mill, and we are not able to achieve the rated capacity because of that also. For an average, for a coil below 0.6 mm, uh, the average processing time at PLTCM is around 12 minutes in the 0.6 and below, and in coils more than 0.6 mm, it takes only 8 minutes. So you can see 4 minutes of difference is there. Also, the for due to narrow coils, like narrow coils, we define it coils below 1200, below 1200. The average weight we get from HSM is around 19.5 as the rated or the design weight of 23. This has also not allowed us to achieve our capacity in terms of tonnage. Then coming to the next section is bell annealing furnace BAF. We have logistical constraints such as cranes. Uh, Loading is done through cranes, and that is and we have a very um, closed window for loading the coils, so it takes a lot of time in that. That has also it is rated for 0.86 million ton BAF, but we have achieved around 0.5 million ton till now. Then going to SPM, we are due to new railway guidelines, we have to partition the coils in 50% of the coils. That most of the coils are of 1900 width. Then going towards coil packaging line.
Excuse me,
Uh,
could you please explain parting of the coil again? Is it width-wise?
like ma'am, for the width of 1000 mm and 900 mm, according to the new railway guidelines, the OD of the coil has to be less than 1.5 meter, I guess. 1.5 times the. So it has to be 1.5 times the width of the coil. So the actual original coil, full coil, what we are producing at SPM will be around 2 meter OD. But
Ashuji, can I ask something?
yes, sir.
There are 2 points. One point says that due to narrow coils, average coil weight is reducing from 23 to 19.5. Already we are
Yes.
From higher weightage to we are coming down to lower weightage. Then again, after that, do we need to do this 50% parting? So,
Yes, sir. Sir, actually, OD in narrow coils, outer die in narrow coils, is higher. It is around for maximum for like our design capacity is 2 meter.
Okay.
So for a 2 meter coil, the OD has to be 2 meter OD coil. The maximum weight can be 20 tons.
Right.
So, but railway is not allowing us to give more than say 1.5 times the like one, maybe you can say 1.5 मीटर से ऊपर हम लोग लोड नहीं कर सकते हैं रेलवे वैगन्स में ड्यू टू न्यू गाइडलाइंस. तो हम लोगों को इन एवरी 900 mm एंड 1000 कॉइल्स हम लोगों को पार्ट करना पड़ रहा है कॉइल को।
डबल वर्क हो गया ये ऑलरेडी।
हाँ, ये डबल वर्क हो गया और इससे एसपीएम का प्रोडक्टिविटी रिड्यूस हो रहा है अगेन एट कॉयल पैकेजिंग यार्ड।
अच्छा,
जो
हायर
हमारा
थिकनेस, इन केस ऑफ हायर थिकनेस आपका जो ओडी है वो क्या बढ़ नहीं रहा है, उसको पार्ट नहीं करना पड़ता है आपको?
सर हम थिकनेस पे उतना वो डिपेंड नहीं करता है हम लोग को। सीजी जो सेंटर ऑफ ग्रेविटी नीचे करना होता है, तो वो
No,
थिकनेस पे।
basically, Niranju, what he is asking na, it is not thickness, it is width. Width 1250 हो गया, 1500 हो गया, उसमें पार्टिंग करना जरूरत नहीं है। तो जो 1000
सर he said thickness, that is why.
no,
Can you explain what is parting part? Is it segregation?
No, ma'am, parting is like you in this picture you can see it is a full coil and the OD of the coil is say 2 meter, but railway is we have to make a smaller coil, like out of this one coil we have to make 2 coils. That is
Okay.
parting into 2 parts.
Okay, widthwise.
So दो हाँ
Okay.
Can I add something? Actually, there
Yes,
was
yes,
some
yes.
accident with wagon loaded with higher what should I say, higher dia
OD.
of coils. So what railway has imposed restriction that with beyond this much height we cannot load into wagon. Is it right, Nilanshi ji?
Yes, yes, sir, yes.
Because of that, whenever the coil size goes beyond something, they need to part it. Instead of कि ज्यादा डाया करे उसको रिड्यूस कर देते हैं ताकि वो जो परमिसिबल है उसके विद इन रहे। तो इसमें क्या
ये
इनको
जो
डबल एफर्ट लग रहा है, मतलब वो बन भी रहा है, ज्यादा हो गया तो फिर उसको रिड्यूस करना पड़ रहा है अलग से।
मतलब
ये
अनकॉइल करके फिर अगेन यू हैव टू कॉइल सम पोर्शन ऑफ इट, राइट? यू आर स्प्लिटिंग वन इनटू टू।
ये मैम हम लोग जैसे अनकॉइलिंग कर रहे हैं एट एसपीएम, देन वो क्या हो रहा है कि हाफ कॉइल जब प्रोसेस हो जा रहा है तो वहां पे हम लोग कट करते हैं।
हाँ, तो बेसिकली आप उस लेंथ को दो में स्प्लिट कर रहे हो, राइट?
हाँ,
No, it
लेंथ
is
को दो में
lengthwise.
स्प्लिट कर
Yeah,
रहे
yeah, yeah. The whole
हाँ,
length is being split into two parts, so that the size is limited to what railway
हाँ, तो
allows.
हाइट ऑफ द कॉइल यू कैन
Okay.
से इज
हाँ,
रिड्यूस्ड।
Height reduces because the outer dia will reduce.
Yeah, yeah.
यस यस।
Okay.
Yes,
तो
yes.
एसपीएम में हम लोग जो फुल स्पीड पे 600 या 700 पे चल रहे हैं, तो वी हैव टू रिड्यूस इट टू 0 फॉर पार्टिंग द कॉइल या कटिंग द कॉइल इनटू 2 पार्ट्स। तो यहाँ पे हमारा मतलब प्रोडक्टिविटी लॉस हो रहा है इन एसपीएम ऑल्सो।
ये सिर्फ थिनर एंड नैरो विथ कॉइल्स में ही हो रहा है या थिकर कॉइल्स और वाइडर विथ्स में भी इशू आ रहा है? लाइक द हाइट ऑफ द कॉइल गेटिंग इंक्रीज्ड और रेलवे से इशू हो रहा है?
मेजर इशू मैम ये 900 विड्थ नैरो विड्थ कॉइल में है, थिनर से इसका कोई ये नहीं है रिलेशन, लेकिन ये सिर्फ नैरो से रिलेशन है। जो 1000 एंड 900 का जितना भी ऑर्डर है उसको हमको काटना पड़ रहा है।
सर व्हाट
और
इज द मतलब लाइक एक अप्रोक्सीमेट अगर मैं वेट पूछूं कि नैरो विड्थ में कितना वेट आप लोग मेंटेन कर पा रहे हैं वो हाइट मेंटेन करने के लिए, मतलब मैक्सिमम कितना जा पा रहे हैं?
अराउंड 9 टन्स मैम, 9 टन्स यू कैन से
Okay.
मैक्सिमम।
8 to 9 टन्स का कॉइल ही आप उसमें दे पा रहे हैं?
हाँ हाँ।
एक्सक्यूज मी, तो ये पहले से ही बड़ा कॉइल क्यों बना रहे थे?
Exactly.
मैम जैसे एक जितना नंबर ऑफ कॉइल्स जो हमारा ये सीआर कॉइल बना है, जो एचएसएम से जो एक फिक्स्ड लेंथ का कॉइल है वो फिक्स्ड फिर सीआर में बना वो फुल कॉइल, अभी हमको उसको जब भी काटना है तो हमको स्लो डाउन करना है, इसलिए हम सीआर में तो वहाँ हम लोग स्लो डाउन नहीं कर रहे हैं। और अगर हम अगेन कमिंग टू बैफ, हम जितना नंबर ऑफ कॉइल्स बढ़ाएंगे तो उतना हैंडलिंग वहाँ पे क्रेन से ज़्यादा होगा। तो प्रोडक्टिविटी बैफ का ऑलरेडी लो एवरेज वेट की वजह से घटा हुआ है, तो हम अगर पीएलटीसीएम में ही हम लोग और स्मॉल कॉयल कट करेंगे तो वहाँ पे पीएलटीसीएम एंड बैफ का प्रोडक्टिविटी घटेगा। अभी क्या हो रहा है कि एसपीएम और सीपीएल का प्रोडक्टिविटी घट रहा है, इसलिए हम लोग को फुल कॉयल लेते हैं एसपीएम में, वहाँ पे हम लोग उसको 2 पार्ट में कर रहे हैं।
I think,
And
yeah, a lot of questions have already been asked. So we will thank you, Nilanshu, for handling all the
मैडम
queries.
एक इंटरप्शन करूंगी
हाँ, sure.
ये जिन लोगों को कुछ क्वेश्चंस पूछना है अगर टाइम नहीं अवेलेबल है तो यू रिक्वेस्टेड टू काइंडली पुट इट इन द चैट बॉक्स सो दैट कि अगर हम लोग बाद में वो क्वेश्चन ले सकते हैं द कंसर्न पर्सन कैन आंसर द क्वेश्चंस
Yeah, that is a good suggestion. Thank you, Lopa.
and the concerned person can answer the questions.
Yes.
Ma'am, just one question. No, it's not a question, a request to Parcha ji and Nilanshu ji. I believe there was some study that has been conducted upon productivity loss in terms of monetary value. Actually, I had interacted with Parcha ji, but somehow we could not get that report or study. So if they could please share this study of productivity loss or in terms of rupees per ton, possibly we could try to find if at all we can push customers to say further relation so that that productivity loss is somehow compensated. A request, please.
Okay, I will take it up with Parichay ji. Thank you. I think one-on-one we can discuss. I am seeing that ED Marketing Shri Sanjay Agarwal sir has joined. Good afternoon, sir.
Good afternoon, madam.
Sir, we have one small session left on GP, which for which we have a faculty from this area. So we will quickly have that presentation before we open it for discussion with.
So I had a couple of points,
Yes.
but I can sit through the GP presentation. For some reasons, I have been required to stay back. I'm not in the office, but I can stay back for the GP presentation. And then I have not exactly a question, but a couple of suggestions for the Parichay and others connected from BSL. So how long do you think the GP presentation will last?
Sir, Parichay, you will have to keep it short, 20 minutes, okay?
Yes,
I
ma'am.
think I would
So
request.
I have no
Nilanshu to-
intention of advising anyone to cut it short. That between Lopa madam and Shabnam, both of you can decide on that.
No, sir, we are already learning late. So,
Okay.
yeah, that was what was advised to them initially. And I
Okay.
request that let Parichay finish his presentation and then we go for question and answer. This is a request to all the participants.
Right.
Yeah, just to make it smooth. Nilanshu, thank you so much for your presentation. You can unshare
you.
your screen. And Parichay, you can start sharing your screen. During this time, I will introduce you. Parichay Bhattacharya, Senior Manager CRM3, Bokaro Steel Plant. He is operations in charge of hot dip galvanizing line of the new cold rolling mill complex. He has done his BTech in computer science and is currently pursuing his PhD in industrial IoT. He joined SAIL as MTT in 2014. He was a core member of the HDGL team throughout the erection, testing, commissioning, production, ramp up and stabilization phases. Expert in this field. His academic publications include 3 international journal publications and 4 papers presented in international conferences. Some of his noteworthy achievements include winner of SAIL CTYM in 2015-16, winner of Director in Charge Trophy for Best Shift in Charge at BSL in 2017, winner of Bokaro Steel Excellence Award 2022 for exemplary performance at work, winner of Platinum Category Award 23-24 from National Productivity Council in 23-24. Young Engineer of the Year Award 2024 from Institute of Engineers, Jharkhand State. Parichay has a lot of more things to his credit, but due to time constraint, we'll limit it till to this, Parichay. I request you to please share your presentation.
Good afternoon, ma'am.
Good afternoon.
Thank you for such a generous introduction. I'm quite sure I'm unworthy of such a grand introduction. Would try to do justice to it.
Yes, please share your presentation and you can start.
Yes, ma'am.
Parichay will be presenting on GP.
Is my screen visible? The presentation is visible?
Not yet.
Okay.
Yeah, now it has come.
Okay. Is it visible now?
Yes, yes. Please continue.
Yes. Good afternoon, sirs. Good afternoon, everyone. I am Parichay Bhattacharya. I look after the galvanizing line. So the idea of this session is my first priority is to restrict it to 20 minutes strict as we are running late. The thing is, this presentation is a bit long and elaborate. So I will be laying emphasis on things which need more discussion, and the rest of the presentation I will be sharing along with some few other documents also I'll be sharing at the end of the presentation, which will act as maybe study materials for those who are interested to go through in galvanizing at depth. Okay.
Yes, yes. I will upload all your material on eAbhigyan.
Thank you. I want to thank MTI also for providing us this opportunity to interact with our seniors and colleagues across SAIL. Let us proceed. So I look after the HDGL. It is the hot dip galvanizing line at CRM3. Like Nilanshu sir was saying, this is the third route. In CR, we have two routes. One is through bell annealing furnace, and the other is the electrolytic cleaning line and then bell annealing furnace. This is the third route of 0.36 million ton capacity of galvanized products that we have. And we take coils from the PLTCM. So cold rolled coils from PLTCM is input of galvanizing line. And we have a dedicated packaging line for packing and dispatch of galvanizing. Moving on, this is a basic generic layout of a continuous galvanizing line. Ours is a continuous galvanizing line. So we have two pass lines in the entry and then a laser welder to join the two coils. This is the loopers. This is the entry looper and the exit looper at housing around half kilometer of strip. So the basic idea is, as it is a continuous galvanizing line, the process we call from this looper to the exit looper, this part we call the process section. So for every coil, there will be coils finishing at the entry and there will be coils unloaded at the exit. During this stoppages of this entry and exit section, the process should not stop. The basic idea is to run the process continuously. For that, this looper houses half kilometer of coil. Till the time the welding and the entry is restarted, the process takes material from this looper. This gets emptied and the process keeps on running. And when there is a stoppage at the exit section for coils cutting and unloading, the exit looper gets filled with the process so that the process keeps on running. We have a cleaning section, which is a clone of the electrolytic cleaning line in the CR route that we have. For CR route, please understand that electrolytic cleaning is optional, but in GP, we can say for all coils as a standard, we give electrolytic cleaning or degreasing. Then we have a continuous annealing furnace. I will be moving on quickly to the line diagram in detail. So after the electrolytic cleaning, we have the continuous annealing furnace where depending on the annealing cycle defined of the material grade we are being processing, we do annealing of the strip. This is different from the bell annealing furnace in a sense that it is a batch process and this one is a continuous annealing process. So in a reducing atmosphere, based on the thermal cycle defined, we do annealing, and after that, there is the zinc pot, and DAC is dynamic air knife. We use it to control the coating weight, depending on the customer's requirement. After that, we also have a provision for annealing, and then after water quenching, we have provisions of skin passing and tension leveling. At present, skin passing is not in line, but for all coils, we are providing tension leveling as a standard. To prevent white rust, as Dr. Sahu was rightly saying that white rust is a major issue in galvanized products across the globe. To prevent white rust, we have two options of passivation. One is chromate-based passivation and other is electrostatic oiling. Commercially, till now, we have only provided chromate-based passivation. We are also capable to provide electrostatic oiling passivation if customer requirement arises. So that's in brief about the oil, the process of galvanizing. In HDGL, we process from 0.3 to 2 mm of thickness, and commercially we process from 900 to 1500 mm width. Coating weights, the line is designed for coating weights of 60 to 600 GSM. Commercially, we have produced 80 to 600 GSM. Line speed is designed up to 150 MPM. This again is subject to several constraints I will be detailing in the later part of the presentation. Our line is also capable to produce differential coated products, like in top and bottom, there will be different coating weights up to 1:2 ratio. And like I was saying, in passivation, we have options of chrome-based and electrostatic oiling. Highlights of our line, we can say we do electrolytic degreasing in 100% of the coils, unlike the CR route where it is optional. Ours is a zero spangle bright finish product. So what is spangle and all, I will be briefly touching upon, and I have reading materials for you to share. We do tension leveling in 100% of the coils. Again, tension leveler is equivalent of what the TLIL line does in the CR route. Again, as a standard in 100% of the coil, we provide around up to 2% elongation through the tension leveling post galvanizing. We use a patented coating prediction model for consistent coating weight throughout the length and also optimizing the zinc consumption part. Chrome-based passivation and oiling I've already told. And we recently, after Rourkela steel plant stopped producing galvanizing products, there was this requirement of a product called third GP, which is basically high hardness strength product. That as well. Our product destination, as I was saying, is coil packaging line 1 for packaging and dispatch. So I will be sharing this slide. This is just the possible size mix. You can appreciate that we don't produce too wide in two thinner gauges and two thicker gauges. We have produced up to 2 mm 1500 width, but I guess this matrix is quite understandable. So it is self-explanatory sort of thing. I will be revisiting it. So just basics of galvanizing, as we all know that galvanizing is process of rust proofing iron by the application of zinc coating. It involves immersing the steel into a bath of molten zinc at a temperature close to 465. The melting point of zinc is 419.5, but I will be sharing a solubility curve. According to the solubility curve, globally, all galvanizers across the globe maintain a zinc pot temperature of 460 to 465. We maintain it at 460 at HDGL. So through galvanizing, we get two kinds of protection. One is the physical protection or the barrier protection. So what does zinc basically do is, above the cold rolled strip, zinc provides a physical isolation of the strip from the atmosphere. It forms an even layer of zinc oxide through the reaction zone, and then a zinc carbonate, which is a very stable layer. So it does not allow the atmospheric oxygen to come in contact with the strip and form an oxide. So the basic objective of galvanizing is prevention of red rust, we call it. Also, zinc provides a self-sacrificing galvanic protection. Given in the slide is the galvanic series. From the top, electronegative or the anodic is at the top and the cathodic is at the bottom. You can appreciate that materials like zinc and magnesium, aluminum, they are above iron and steel. So when there is an oxidizing environment present, the zinc tends to self-sacrifice itself to protect the underlying iron. Basically, our line is also designed for galva annealed. See, these are, I am not going in detail due to want of time. These materials will be shared with you and we can have a discussion in any specific topic if you want to have. After this presentation is over, I will be sharing my contact details also. At any point of time, we can have a discussion. Galva annealed is basically annealing after galvanizing, where after the strip passes through the zinc pot at around 460 temperature, it is reheated again around 580 to 590 degree, which allows for the iron in the strip to diffuse into the zinc coating and create what we call 3 different layers as shown in this picture, this is a GI, a galvanized iron normal GI coil. And these are the three different layers, the zeta, delta, and gamma layers with different percentage, varying percentage of irons. So it allows for the iron to diffuse due to the reheating after it is passed from the zinc pot. So it gives a more matte sort of a finish, but it improves the corrosion resistance and also improves the alloying of the zinc with iron. If we compare galvanized and galvannealed, in galvanized, it is pure zinc, and it is a zinc iron alloy for galvanized. Appearance, like I was saying, in GI, we have a shiny metallic surface. It is a dull matte gray surface for GA. However, the paintability is excellent due to the iron diffusing into the zinc coating. Weldability is improved in GA, and also the coating of GA is harder and more scratch resistant. You can understand because in GI on the top layer we have pure zinc, and in GA till the top layer we have some percentage of iron getting diffused into the coating. Other hot dip coatings I will not be covering in detail, but galvanized coating, it is only zinc. The STM specifications are given here. In galvanneal, it is 10% iron. Aluminium zinc is 55% aluminium and rest zinc. This is Galvalume. We call it commercially, it is sold as Galvalume. Zinc 5% aluminium, zinc aluminium. This is called Galfan. This is commercially sold as Galfan. This is ZAM coating, zinc, aluminium, magnesium. See, all these are zinc, aluminium, magnesium are three different elements over the galvanic series over iron. And this is aluminized or pure aluminium coating. So we can have detailed discussion in any of this, but it will require a lot of time. So this is basically a comparison of Galfan, hot dip galvanized, electro galvanized, galvanneal, and Galvalume. Note that 5 is the highest and 1 is the lowest. Quickly moving on to the continuous galvanizing. Commercially, we are producing DQ grade steel. So we follow the thermal cycle defined in the second row of this table. This is the thermal cycle, this blue curve we follow. And note for galvanneal, this is the zinc pot area basically. For galvanneal, it is a reheating to 580 to 590 degree after the strip has passed the zinc pot and then cooling it back to the room temperature. So we strictly follow this annealing curve so that our material properties are consistent across the length of our products. This is a bit of depth in galvanizing. I will be just telling that our zinc pot has around 0.4% of aluminium, 0.4 to 0.45% of aluminium in the ingots that we charge. And there is this thing called effective aluminium, which comes to around 0.18 to 0.2% that we maintain in the zinc pot. The aluminium, what it essentially does is it inhibits the reaction between zinc, the fast reaction between zinc and iron. The fast reaction between zinc and iron causes an intermetallic alloy zone, which is very brittle. See, this is a cross-section of the coating produced from an aluminium-free galvanizing bath. So this intermetallic alloy zone is very brittle. So this is a very thick intermetallic zone. After adding aluminium, what it does is it makes an intermetallic called Fe2Al5, Fe2Al5ZnX we call it. So the alloy layer becomes thin and above it, it becomes a thick zinc coating layer. So the brittleness is gone and now the material can carry the weight of the zinc over as the coating. Like I was telling, at 460 degree, this is the solubility curve, and at aluminium percentage above 0.14%, all that we have is what we call top dross, which is Fe2Al5ZnX, and below 0.14 in in galvanneal coating, we need to maintain a pot chemistry where the aluminium is around 0.115 to 0.13%, which is below 0.14. So we have a lot of bottom dross. Now this brings us to the term called dross. See, dross is an unavoidable part of galvanizing process. It is formed because of this formation of this intermetallic when there is an enhancement of aluminium over 0.14%, all the dross, it is basically what we say the cream over milk. We have a molten zinc pot where the liquid zinc is there. On top of the liquid zinc, like milk floats over cream, cream floats over milk, the top dross floats over the pot, which we need to manually skim and remove. In bottom dross, it settles at the bottom of the zinc pot. So Galva annealed suppliers, they need to do a GA to GI changeover by adding more aluminium so that all bottom dross, either they are removed through what we call dross grabs, or it is metallurgically converted into top dross by adding an enhancement of aluminium, and then it is removed as a top dross. So that we call GI to GI changeover. Moving on, I have faced this question from many of my counterparts that whether we provide spangled GP coil or not. Because to the understanding of our customers, a few section of our customers where we have been historically supplying galvanized materials, they used to prefer spangled galvanized materials. They call it the full patti wala GP. They want the bright shiny surface. I'm quite sure you must have faced this customer query that whether we can provide spangle or not. Historically speaking, we have been supplying spangled GP from our old galvanizing line, but from 2018 onwards in CRM3 HDGL, our product is a zero spangle. So what is a spangle? Spangle is basically the way the zinc cools down after it passes from the zinc pot. It cools down, and these patterns are formed where there are grain boundaries. So this reflects light in a way which gives an illusion of a reflecting surface. But it has also been researched that around these grain boundaries, these are the areas where the corrosion starts to begin. So due to rapid cooling, we can avoid this spangle formation, which to be honest is a defect, but has been sold in the market as a feature since long. The answer to the query is given in the last line of this slide. The products from HDGL CRM3 are spangle free. We don't provide spangle GP coils. There are three kinds of spangle: regular, minimized or crushed spangle, and spangle free, the product we are making. Please invest some time to go through this material, and if required, we can have a discussion. See, this is the large size spangle. This is medium spangle, small spangle, and spangle free product that we are making. So we don't give this kind of full patti wala GP. Our GP is sort of a vanilla GP that we produce. It is very important to understand that how we control the coating thickness. After the material process from the zinc pot, we have what we call the DAC, or the dynamic air knife. We use a small orifice where we have high volume of air. We throw high volume of air. The pressure of the air cuts through the molten or the semi-solid zinc, and this is the returning zinc to the zinc bath, and this is the solidified zinc. If W is the coating weight which I am desiring, it is a function of four different things: the line speed at which the strip is passing, the pressure at which I am throwing the air, H is the horizontal distance, the distance from which I am throwing the air, and E is the opening of this edge opening. So these four things dominate the coating weight. Why am I discussing this? I will be detailing about this in later part of the presentation. Like, to attain a lower coating thickness, our line speed has to be reduced. The pressure has to be increased, but the pressure can increase till the limit the blower is designed to handle. The horizontal speed can be brought closer so as not to damage the strip or the air knife. And this edge, for our case, it is fixed at around 1.2 mm opening. So this is the cross section of the strip. The strip comes somewhere here from the furnace, and these are the submerged pot rolls. We call it the sink roll, the pass line, and the corrector rolls. These are the stabilizing rolls. And here, somewhere here is the air knife, and the strip passes like this. It is very
So,
important to
presently we are
maintain
using air
the
knife for
flat strip between the air knife. If the strip is like this, so our target zinc coating will also be different in the top and bottom side. So this is the basic idea I wanted to share. Now coming to the quality issues. See, for our understanding as a galvanizer, we understand that quality is defined by the customer. A quality product or service is one that meets the customer's requirement, and not all customers have the same requirements. Therefore, two contrasting products may be seen as quality products by their end users due to their different end uses. To facilitate price fixation and ensure the market's trust, consistency in quality is important. So if we make poor quality GP, if we keep on making poor quality GP, I'm quite sure we will have a market which requires that quality, and at a substandard price, we will be selling it. And if we make good quality product, we need to consistently keep on making good quality products. So this is basically the service life of hot dip galvanized sheet. This is time to 5% red rust in fully exposed outdoor condition. See, this is G40, G60, G90 until G210. So this is service life in years. In our galvanizing line, these are the top 5 to 6 defects that we have faced, and the kappa is attached. Zinc peel-off is a very old issue. This was the issue which plagued us when we just started the line in 2018-19. We had several complaints of zinc peel-off. It is basically poor adhesion of the zinc, and when the customer used to bend our product or form our product for some end use, the zinc coating used to give off and peel off. So we found the root cause was the supplied nitrogen, the inert atmosphere that we create inside the furnace was having a high oxygen percentage. It was causing our strip to get oxidized before it used to reach the zinc pot, and due to this oxidized surface, the zinc adhesion was poor. But since last 2 years, we have 0 complaints of zinc peel-off because we have a dedicated nitrogen pipeline for HDGL, where we strictly maintain below 10 ppm of oxygen in the nitrogen supplied. So we are having a continuous monitoring for this, and thankfully we don't have any peel-off complaints. White rust is one thing which plagued us around last 2 years. Again, the root cause, as Nilanshu sir was saying, that we found out that more in Resilex packed coils, we used to have more complaints of white rust. So we have done away with Resilex packaging due to several customer complaints throughout the country. And thankfully, the white rust problem is resolved. We also strictly monitor the conductivity and the concentration of the passivating solution that we have, the chromic acid solution, and so that the chemidite film that we give for white rust prevention is well formed. Scratch marks in thinner gauge, in very few coils we have this scratch marks issue. It is mainly due to stabilizing rolls not rotating in thinner gauge. You understand the submerged rolls inside the zinc pot, they are at 460 degree and there is no electric motors or any mechanism to make it rotate. The strip, the running strip makes it rotate. So in thinner gauges, there is not sufficient tension provided by the strip so that it can rotate. And when there is a speed difference between the rotation and the linear speed of the strip, there are scratch marks visible. So our procurement action is already in progress with hollow stabilizing rolls. Presently, the issue is tackled with adjustments in tension of the zinc pot and modifications to the air knife. Edge waviness is an issue which around, what do I say, around 0.1% of the coils we had received edge waviness complaints in thicker gauges, thicker and wider gauges. We have installed new tension leveler units in the month of August end, September. So this problem won't repeat now. Rib formation is another term which is essentially due to the ridge coming from the HR coil. Nilanshu sir has already discussed, and this problem is also solved to a great extent post the modernization of hot strip mill in 2024. Another problem which the customer often mistakes as white rust or white bands. Please understand that white rust, it may look like white bands, but when you scratch the surface, if there is a powdery mass coming out, it is white rust. If it is a band, it will aesthetically look poor, it will look bad, but when you scratch the surface, the coating would not peel off, or there won't be any powdery mass coming off when you scratch it. These are due to thermal bands from the HR coil. What happens is, after the recoiling is done at the exit of hot strip mill, the center of the coil and the edges of the coil lose heat at a different rate. This forms a thermal band in our input coil. So if we heat it evenly across the width, these bands sometimes reappear after the galvanizing. It is purely well galvanized, but it would have a shade difference. So in aesthetic sense, the material would not look good, very good. We have solved this uneven thermal band issue with an uneven heating mechanism, which we have developed in-house. So this problem is resolved now, and we are making more and more efforts to ensure that our customers are well informed that what is a white rust and what are white bands and what are the difference. Please understand that this HDGL is a finishing line, so we have to be very stringent about our quality of the product that we are giving. Galvanizing again is not a painting technology, so no scope of camouflaging any defect. If there is a defect, it will show after galvanizing as well. In galvanized products, we don't have any downgradation possible. In CR, we have a thing called CR1 SD, the downgraded CR product. In galvanizing, it is either prime or scrap. Like I was telling, it is a continuous galvanizing line. So every stoppage of the line causes 5 to 15 tons of scrap generation, because the material inside the furnace and the material inside the zinc pot, we have to discard it after every stoppage. So depending on the thickness and width of the coil, around 5 to 15 tons of scrap is generated with every stoppage of line. As Dr. Sahu was saying, that our products primarily conform to the IS 277 standards, but from our practical experience, we can tell mere conformance to the IS 277 standard does not ensure customer satisfaction. So we need to be very careful about what we are providing. More importantly, what our competitors are providing, and so that we are at the same level to compete with them. Our efforts have borne fruit, and you can see the diversion percentage from HDGL has consistently gone down. In financial year 2023-24, it was around 4%. And we have been working on it, and we are trying to bring it back. And thankfully, till now, in the first week of November, it is only 0.87%. We are operating at around 2 to 2.5% at present, and we are doing our best to minimize it further. I will not be elaborating a lot about white rust, because Dr. Sahu has already explained the metallurgical aspects of it. Just a thing that white rust, contrary to popular belief, is not zinc oxide, it is zinc hydroxide. So for white rust formation, there should be simultaneous presence of water and oxygen. And let's say in cases where there is abundance of air, their white rust formation chances are very less. Like in roofing applications, galvanized steel is used in roofing applications, but white rust formation does not happen there. What happens is, if there is a water carryover in the coil and it gets inside the packaging, there is no ingress of outside air, and there is water inside the coil. So these reactions can go through very well, and leading to the formation of zinc hydroxide. The photo is attached, what is called white rust. Prevention of white rust, like I was telling, we use a chromate based passivation. We basically spray chromate based solution so that the chemidite layer is formed, and we have these squeezy rolls which can wipe off the chromate based solution back to the tray, and this recirculation process goes on. Details of white rust I can skip. So salt spray test is the test where it is used to ascertain the passivation quality. See what is done is, this is the salt spray machine where the samples are cut and a certain standard percentage of NaCl solution is sprayed to these samples, and the time to 5% white rust, time to 10% white rust, 5% red rust, and 10% red rust are noted down. See, this is the condition where it is a moist, salty atmosphere in a temperature which is conducive to white rust and red rust formation. And in this accelerated situation, we note down the time. At present, our white rust duration is around 100 hours we are providing. So salt spray duration of 100 hours is more than the standard in India, and we are strictly providing it. Moving on to the product development and upgradation, some recently developed products, apart from the GI products that we make, we have supplied GP350 600 GSM for solar panel applications, GP350 275 GSM for food grain silos as an import substitute. We have also supplied high strength GP with 350 YS and 420 plus UTS with 12% elongation in 275 to 600 GSM. This is our patented product. We filed an Indian patent for this product in March 24. Like I was telling, after RSP has stopped producing GP, to retain their market segment, we have also ventured into providing high hardness material in lower thickness and narrower widths. In future, we also plan to foray into the differential coated products for fuel tanks and roofing applications. We are moving towards invisible ink printing for our color coating segment customers. And also we will try to make products which have properties similar to dual phase steel in our galvanizing line. We can have inputs from you, any other product which the market requires, which can be of good realization for us. I will make it a point to note it down during the Q&A sessions. Please keep in mind about this. So this is our product contribution data. Although we don't enjoy much control over it, it is dominantly dependent on the market. So just for statistical purposes, I'm sharing this data with you. This is our NSR and contribution data for the last 6 months. Moving on to the rolling challenges and constraints part. See, when I talk about HDGL, HDGL is designed to make 0.38 million tons per year, which roughly comes to around 31667 tons per month. But till date, HDGL has only processed around 2190 tons in September 23 is our record, and we have been consistently making around 17,000-18,000 per month. Our ABP target stands at around 20,000-21,000 per month. For months having 30 days, it is 1950 and 19,500, and for 31-day months, it is 20,000, our ABP target. Important to note here is the running length that we have achieved. See, to convert this 31,667 tons per month, this is the design document. The snap of the design document I'm sharing. If you add these two figures, it will be 0.38 million tons. So, but to achieve 0.38 million tons, our line should produce this type of coils in these proportions. That is what the design document says. It is important to note that in the design document, there is no calculation taken for 900 width coils. Our line is not supposed to produce a single 900 width coil so as to achieve this rated capacity. I am telling this much because in various interactions with my CMO counterparts, I have been questioned that your line is designed to run 32,000 per month, but you have only reached around 20,000 per month. What is the reason? I thought it would be a good platform to share my experience, why we haven't been able to reach that level till now. So if we translate this amount, these quantities into running lengths, so to achieve rated capacity, we need to run 33,88,967 meters per month based on this segregation. Also, the same document which gives this product, this breakup, the conditions for reaching guaranteed values, this part says the recommended line operating condition is line speed 75 to 100% of maximum speed with a coating thickness of 180 to 250 GSM on both sides. So this is the OEM recommended line operating conditions. So there are four major issues. The weight versus length paradox. Please understand, if we open up a coil, this is how you calculate the length of a coil. Keeping the steel density at 7.85, the standard, we can calculate the length of a coil from the thickness, width, ID or OD, and the weight. So what is the paradox? The paradox is all processing is done throughout the area of the coil. We give the treatment, the galvanizing treatment is given in the area of the coil, and the production is measured in tons. All KPIs are measured in terms of specific coil weight, like zinc consumption in kg per ton, alkali consumption in liters per ton. But our treatment is given in area or length. As the maximum line speed is fixed, so the maximum length that can be processed by the line per unit time is fixed. In thinner and narrow coil, the specific weight is low. So as a result, the productivity in tons per hour suffers even at the maximum line speed of kilometer per hour. There is no technical issue in processing thinner gauges at HDGL CRM3, apart from the fact that our productivity is massively hampered. We have successfully processed 0.3 mm finished product, the thinnest gauge HDGL is designed to run. As the order proportion is skewed, our productivity is massively affected. How? I will be elaborating in 1-2 slides. So the effect of thinner, narrow, and low GSM coils. So in thinner coils, low weight per unit length, poor quality in lower speed. In thinner coils, our line speed cannot be reduced, let's say below 100 mpm, meters per minute. It is due to the fact that the coating becomes rough and the appearance becomes unacceptable. And in higher gauges, as our blower's speed is and the blower pressure is limited, it is very difficult to maintain low coating weight, let's say 80 GSM, which is our standard for around 80%, around more than 90% of the coils we produce. So in lower line speed, we have an issue of poor quality. In higher line speed, although the quality is good, the zinc consumption is too high. Zinc consumption, as say, in kg per ton. In narrow coils, it is low weight per unit length, high roll consumption rate, because when we run long spells of narrow coils, all the PU and rubberized rolls have groove formation of that width, let's say 900. And after, when we switch to wider coils, let's say 1250 or 1300, so we have issues of carryover, so that we need to change the rolls again. So there is roll consumption rate massively goes up. Mandatory line slowdown to cut each coil. This thing has already been explained by Nilanshu sir due to railway guidelines. This holds good for galvanizing also. In 900 and 1000 width coils, every coil is cut in two parts. So the line has to come from its maximum speed to 0 for twice every coil so that it can be cut. And again, in the dispatch yard, there is a space constraint because ours is not a vertical stacking type dispatch yard. Hence, the number of coils get doubled for 900 and 1000 width. So there is a serious space constraint, which also affects our upstream processes at times due to space constraint in the dispatch yard. In low coating weight, let's say we process around 95% plus cases, our line is designed for 60 to 600 GSM. But for 95% of the cases, we produce 80 GSM, which is towards our lowest GSM. So due to lower zinc consumption, due to lower zinc coating, the realization is poor. It is very difficult to maintain a low coating weight in higher line speed due to reasons I have already explained. Difficult to maintain quality in thinner gauges, and also there is a zinc wastage and higher dross formation due to high air pressure creating more turbulence in the zinc pot, leading to higher dross formation. Regarding realization part, last week I had an interaction with one of my seniors at the corporate office, and I was pleasantly surprised to know that ISP Burnpur their foray into the special grade steel is around 90 to 95%, whereas for Bokaro Steel, it is around 10 to 12%, which is very less. So our realization can only improve if we can expand that bracket of special steels that we supply. Specifically for CR, in earlier cases, we had this LPG market, which now with piped gas supply, the LPG market is not there. It has come down. So we have to diversify into different product grades so that we can take benefit of that improved realization. So that is one thinking point I wish to share. See, this is
So
the
may I ask a question?
yes, please.
Parichai, there is a question.
Please.
I just wanted to ask, what is the minimum MOQ quantity in special grades that you require? Madam, if someone is asking
It
for
is
275
one
GSM
hit,
GP,
ma'am. One hit around 250 tons.
around 250 tons in single thickness or width size, or it can be like
For a single chemistry, it is one hit. For
for
a
a
single
single
chemistry,
chemistry. If
it is
I
one.
can have orders like for 275 GSM and 0.8, 0.6 and 1 mm include,
Definitely, ma'am. Yes,
and that would
definitely.
be of 250.
Correct.
Okay.
Then width will
MOQ for
be
any specific chemistry is one hit. One hit translates to around 250 to 60 tons.
Okay.
And width should
Okay.
be.
I am towards a very interesting part in my
Parichai,
presentation.
there is another question from Prayagraj. I think Pramodji
Yes,
from
sir,
Prayagraj.
please. Sir, please.
More this side. Could you please get back to the previous slide?
Yeah. Yes.
Okay. Here, in the last para, we are saying low coating weight is causing high dross formation, but rather
Correct.
I'm dealing with two set of customers. One is consumer and others are dealers. Dealers are mostly preferring thinner gauges. You might be knowing.
Yes.
0.5, 0.4, 0.5, 0.6 is their choice for trade and other purposes. However, my consumer, which is mostly dealing in thicker gauges, 1.2, 1.5 and 2 mm.
Right.
Up to in 120 GSM, I have found out is quite the contrary. We have found out 1.5 and 2 mm has mostly dross formation, and the kind of quality complaint that you might be aware. We have in recently at least filed 3-4 quality complaints, and most of the complaints were in 1.5 and 2 mm with the zinc splatter and dross formation.
Sir, higher dross formation, the perspective is different. I understand your question completely. Higher dross formation in the zinc pot here in the PPT, and you are talking about the dross carryover in the coils.
Into the coil, right.
Right. So higher dross formation in the zinc pot is due to the greater turbulence of the air knife blowers, right? For lower GSM coils. For higher thickness, what happens is if for some reason there is a line slowdown, there is the blowers take time to come back to. Suddenly, if there is a line slowdown, the blower pressure needs to be reduced immediately. But you can understand it is a physical thing, so the RPM reduces at its own speed and it takes some time. So what happens is the coating gets rough. We try to discard that part, but due to the continuous nature of the line, sometimes it goes through. And that causes the customer complaint. The customer calls it the dross carryover. It is essentially a rough coating. If you can do metallographic analysis of the complaint, so rather than dross, it will be a rough coating due to uneven air pressure, or what do I say, turbulent air pressure through the air knife, which the customer complains as a dross carryover. Dross is entirely dependent on our pot's chemistry. And the pot's chemistry that we maintain, it is very difficult to have bottom dross. And for top dross, if the pot's dross level is maintained, it should be similar behavior for thinner as well as thicker coils. So I am quite understanding, I am understanding the point you are trying to make. The customers complain it as a dross carryover, rather it is due to turbulent air pressure of the air knife. It is a rough coating, sir, due to some interruptions during the continuous production process. But if there is an abrupt line slowdown, this slowdown part goes as rough coating.
I could try to understand that, because most of the cases were from single batch or single what should I say shift material, because what we could find is the CA dates are quite very nearer to all the coils that we had found complaint with. So possibly what you
At present, our drossing practice is entirely manual. We don't have any robots. Like few of our peer competitors, they use robots. In Bokaro Steel Plant, we are doing manual drossing. You understand that in any process, if there is a manual intervention, the quality of job gets affected due to the quality of the manual labor also being employed. I'm not saying that it cannot happen. Like you have rightfully mentioned, if it is the coils from the same shift, maybe we need to increase the drossing frequency. I would be requesting you, sir, to please share the coil numbers. I will be backtracing it and coming back to you with the detailed kappa.
Also kindly share the photo. If you are getting such sort of thing, na, try to share the photographs.
Sure, sir. Sure. I do have that.
Sir, may I proceed? I am towards
Parichai,
the end of-
yeah, we are already over. We have overshot by more than 30 minutes, so you'll have to wind up so that you know we have the last
in 2-3 minutes,
section.
ma'am, in 2 to
Yeah,
3 minutes.
please,
Yeah.
yeah.
The point I'm trying to make is this is the analysis of HDGL's production in October 2024. See, as per CTS, to reach this rated production, if we break down in 12 months, we need to process around this amount of length. In October 2024, HDGL has run for this amount of length. So we have processed around 99% of the rated design, but our production is around 55%, 56%. It is primarily due to, in thinner gauges, this split is around 15 to 16% below 0.5. We have produced around 28%. Below 0.6 is 32%. We have produced 54%. Below 0.8 is 52%. We have produced 71%. And for narrower coils, we should not be processing a single 900 width coils, and we have processed around 56%. So that is the point I'm trying to make. How thinner, narrow, and lower GSM coils massively affect our productivity. These are the commercial figures. I will be sharing the slide. You can go through how a thinner and the thicker coil, it is the zinc consumption and additional cost of zinc per ton. In a thinner coil of 0.3900, per ton 10 to 11,000 rupees of zinc is used. For a thicker coil, if I take in per ton, it is around 15 to 1600 rupees. So it is for my commercial counterparts to analyze and understand. I will be sharing this document. And like Nilanshu sir was saying, the effect of width and thickness in productivity. See, for a coil weight of 20 tons, for 0.29 900, if it is a 20-ton coil, the running length will be 9762 meters. And if it is a 1.99, it is 2 mm coil, 2 mm 1250 coil, the running length will be 1000 meters. It is 10 times for a thinner to thicker, wider to narrow. So if we count our production in tons, so it will be very dependent on the type of coils that we produce. And to share my pain point, this is the order trend of the coils that we have already produced in the last 6 months. In financial year 2023-24, less than 0.5 was 10%. And in November, the first 10 days of November, it is 42%. Below 0.8, it was 29% in 23-24, and this month it is 83%. So if such a skew in order proportion is there, even for narrower coils also. In 23-24, we had 46%, which itself was very high. In November, we are operating at around 70%. And 80 GSM coils, 23-24, it was very high at 83%. Now it is 95%. Practically all the coils are 80 GSM coils that we are producing. To maximize our productivity.
I have a question. I mean, I have
please.
a thought. So instead, the analysis that you've shown is in terms of quantity. If you could do this analysis in terms of realization, maybe there's a trade-off, right? So for lesser thickness, you get better realization.
Ma'am, this is the realization analysis for coil IDs I have shared, and these are the sale order values, right?
Really sorry, I'm
For
interrupting again, boss.
yeah, please.
Do we understand it like this? The third last column wherein we are discussing difference considering only zinc consumption as difference. So is it like 725 and 800 rupees per ton is additional cost that we are incurring in 0.5 900?
Sir, in this coil, 725 and 800 are the additional, are the profits that we still have due to the enhanced
Profit we
realization.
have. Okay.
In negative figures, only if I take the cost of zinc, please understand the production rate, production time, the electricity cost that I have due to a coil taking 10 minutes to process and a coil taking 40 minutes to process will take 4x electricity and all the costs. I am leaving aside everything. I'm just taking the price of zinc and taking that in this coil, let's say 0.8 900, there is a loss of 1150 rupees per ton. If due to, because the realization is not that high like it should have been.
Just a second.
Yes.
So
Yes,
do I to believe what your study says here is 0.5 900, 0.4 900 is giving us positive realization rather than 0.8 and 900 wherein we are losing 1100 rupees per ton in zinc coil? Is it not?
Yes, from this data, this is, please understand, this is around only 15 to 20 coils data. From this data for 0.8, we don't get this additional brace overprice due to the thinner gauge rolling, we don't get that. But our production time is around 20 minutes for one coil and ton per hour is 25 tons per hour only. For thicker gauge, it is around 50, 55, even it goes up to 60, 65 tons per hour in thicker gauges.
Parchaji,
yes,
we'll get again to the third last column, wherein you are saying for 2 by 900 width material, we are only realizing 100 rupees per ton, wherein 0.5 900, we are realizing 800 rupees per ton. For 0.4, we are 2400 additional we are getting.
Sir, please understand, when I am using this 2 into 900, my per day production will be 1200 to 1500 tons
what
per day.
you can do is you can reduce all of them to a scale of, to the similar scale and then see the realization. Because here all the figures are different.
I will be definitely doing it. I will be doing it. Just the point I was trying to make is in 2 mm coils, if I run 2 mm coils throughout the day, my production will be around 1500 tons per day. Whereas if I run 0.3 mm coil throughout the day, the production comes to around 350 tons per day. But so in this coil, even if the per ton realization is less, I will be getting more volume, sir.
But boss, already you are.
You have to see the product of both, like
100,
130 rupees into 50
just a second.
tons.
Yeah, please. Parchaji, here you could see 100 rupees or let's say 200 rupees and there is 2400 rupees. So सीधे ratio जो है आपका 2 और 24 का है boss. कितना 12 का.
Our
1:12.
Also our running length is also 10:1.
Okay.
Also,
so can we not factor in the length and the time taking in terms of rupee? This is what actually is more what should I say, realistic picture. Instead of saying only zinc saving में जो हमको 2400 हो रहा है, आप प्रोडक्शन और रेट के हिसाब से उसको एट पार लेके आए तो पॉसिबली पर टन में हमको एक्चुअल पिक्चर दिखेगा. इंस्टेड ऑफ 25 हो सकता है वो.
Yes, sir. Sir, I will be doing a detailed analysis and I will be also adding other components also. Costs incurred in alkali consumption, chromic acid. I will be doing a detailed costing and we will be having a good discussion around this.
Yes, that will give a better picture, definitely.
Just my point of view, rather field point of view, I would like to give you. See, RSP was making around 7,000 to 8,000 tons per month. In GP, in your 0.4 to what should I say 6 वाला segment, boss ये segment directly आपको मिल गया है ना? Or the trouble is it's a very stable kind of segment wherein we are getting regular orders for that. Or it's just a trade-off कि whether we not to serve this segment or not. It's not about कि हम बना सकते हैं नहीं बना सकते, but realistic picture रहे कि कितना extra हमारा खर्चा हो रहा है तो हम एक मतलब करेक्ट जजमेंट ले सकते हैं कि इसमें करना है या नहीं करना है.
Sir, my point is, I have already told there is no technical issue in processing any thinner gauge.
Right. We are
point is the realization should justify the efforts.
Exactly.
So I will be doing a detailed analysis. Thank you very much for such an insight. I will be doing a detailed analysis, okay, so that I will be in a better position, because now at this time I have taken only zinc. I have to take into consideration other factors also.
Right.
The running length, electricity, alkali consumption, chromic acid consumption, manpower cost. प्लांट चलाने के लिए जो एक्स्ट्रा खर्चा आता है हमको सब कुछ लेना होगा सर.
बिल्कुल
And
बिल्कुल.
then I will be able to tell you specifically for what thickness and what width, what should be the realization, so that we are at a par level.
I'm sorry to intervene. We'll have to stop it at that. Because
Yes,
people.
the presentation is over, ma'am.
Yeah. Thank you so much. Very interesting discussion. But I'll have to stop because people also have to go for lunch. Thank you, Pariche, for such an insightful session, and thanks for the participants also for making it so interactive and interesting. And now we come to the end of the our session. Our next segment is on market scenario, customer demand, and customer feedback. Pariche, you can unshare your presentation. I request our product executives from CMO to please share, ask your questions. All the faculty are present to answer your questions. You can please start. Any questions from the CMO participants? Yeah, any questions? I request everyone to please switch on your videos now that the presentations are over.
Ma'am, I had typed my question in the chat box. What is differential coating capability?
Yes, who will be answering that from the plant? Differential coating capability?
Yes, Pariche here, please, ma'am. Our differential coating capabilities are 1:2. Up to 1:2 we can give.
So what does it mean, 1:2?
1:2 means, ma'am, let's say in one side you can have 60 GSM, and on the other side you have 120 GSM. Combined it will be 180 GSM. So that is our limit.
Now, are you getting any such inquiry from CMO side? Are you getting any such inquiry? Differential coating? Okay.
There was a question from Rohit Huda in the chat box. Sprangle of various producers were of different patterns like star and other types. So was it a defect?
See, sir, there are three kinds of spangle. One is macro major spangle, one is crushed spangle or micro spangle, and other is zero spangle. Spangle, it depends on the pot chemistry. Earlier, some producers used lead in their pot. It is now banned due to toxicity. Some players use antimony. These are all grain refining agents. So these refine the grains, allows for the proper spangle formation. So, and if slow cooling happens after the material passed the pot, so it depends on the degree and size of the spangle getting formed.
Okay, Rohit, does that answer your question?
यस मैडम. मैम सर एक चीज और पूछना था, ये जो से हम लोग अभी वाटर इन रश हो जाता है जीपी कॉइल्स में, तो या सीआर कॉइल्स में, इसका कुछ फर्दर कर रहे हैं क्या सर इसमें, एडिशनल कुछ इसमें?
बस वाटर इनग्रेस के लिए तो CRM3 में अभी हम लोग इंश्योर किए हैं कि जो रूफ का इश्यूज था वो हम लोगों ने सॉर्ट आउट कर लिया है, तो लगभग रूफ का इश्यूज अभी सॉल्व्ड है. और जीपी कॉइल में वाटर इनग्रेस अभी नहीं होगा. मैं जीपी के लिए स्पेसिफिकली बोल सकता हूँ बिकॉज आई एम श्योर कि इस साल मॉनसून में भी जो कॉइल्स निकला है, वी हैव स्टॉप्ड द लाइन. अगर कॉइल में पानी गिर रहा है तो वी हैव स्टॉप्ड द लाइन, बट वी हैव नॉट प्रोड्यूस्ड जीपी इन दैट कंडीशन.
Any more questions?
अभी तो देखिए बारिश नहीं है, अभी तो आपका पास कंप्लेंट नहीं आएगा. तो लेकिन हमारा जो BSL कलीग है, हम लोग इधर वी आर लुकिंग इट सीरियसली. देन हम लोग वही देखना है कि बिफोर रेनी सीजन, समर का पहले ये फिर we should double ensure that रेनी सीजन का फिर ड्यूरिंग रेनी सीजन ये कंप्लेंट नहीं आए. अच्छा, आइए बे क्वेश्चन टू ऑल सीएमओ कलीग्स जो जो लोग जीपी का ऊपर डील करते हैं. आपका पास हाई स्ट्रेंथ जीपी 450 एंड एबव ये रिक्वायरमेंट किसी कस्टमर से है तो जरूर आपको इंक्वायरी करिए और हमको ऑर्डर दीजिए. वी हैव ए टारगेट, प्रोडक्ट डेवलपमेंट टारगेट ऑफ 450 जीएसएम एंड एबव वाईएस.
तो
350
उसमें मिनिमम ऑर्डर क्वांटिटी क्या रहेगा सर? ये 550 जीपी का अगर आता है कुछ तो देयर वाज एन इंक्वायरी.
450 से हम लोग स्टार्ट करते हैं. 550 है तो बताइए, लेकिन इनिशियली वी वांट टू प्रोड्यूस 450. तो मिनिमम क्वांटिटी वही रखे, 1 हिट का टारगेट रखे जैसे परिचय बता रहा होता ना. तो
250
आपका
टन्स.
ये रहेगा 250 टन्स या 200 टन्स आल्सो यू कैन गिव.
सर एक ये रेनी सीजन में जो वाटर इनग्रेस वाला इशू था, वो एक और मतलब देयर इज वन मोर प्रॉब्लम आल्सो कि ड्यूरिंग ट्रांजिट मतलब व्हेन द कॉइल्स आर केप्ट इन द वैगन्स और वो ड्यूरिंग ट्रांजिट अगर कभी बारिश वारिश होता है तो उस टाइम पे भी उसमें इनग्रेस हो जाता है नीचे वाले पार्ट में कॉइल्स के. सर उसके लिए भी कैन वी मतलब डू समथिंग अबाउट इट?
तो पैकिंग चेंज किया गया है ना अभी. जो पहले रेजिलेक्स पैकिंग हो रहा था तो पैकिंग चेंज कर दिया
सर
गया है कि, और
उसमें
वो
पैकिंग के
कॉर्नर वाला
अलावा क्या
पैकिंग में भी
हम
कुछ
लोग
इशू था. दैट दे हैव डन. सो दिस शुड नॉट कम. स्टिल शॉप
सर ये
का
मतलब
तरफ से ये भी
प्रीवियस
ध्यान रखा
मॉनसून
जाए.
और इस मॉनसून के बीच में पैकिंग चेंज हुआ है.
हाँ, ये कब ये हुआ है परिचय? मुझे लग रहा है कि 5-6 महीना हो गया ना, 4-5 महीना परिचय.
6 months हो गया है सर.
6
बिफोर
मंथ हो
6
गया.
months.
सर उस मे आई स्पीक सर, क्या उसमें हम लोग ये भी कर सकते हैं लाइक अदर कॉम्पिटिटर्स आर डूइंग कि जब वैगन से मटेरियल आता है तो वो लोग उसको टारपुलिन कवर्स करके भेजते हैं सो दैट के जो रेन्स है वो पानी मतलब वहाँ पे डिपॉजिट नहीं होता है. कैन वी यूज दैट ऑल्सो?
Who will be taking that question?
Ma'am, we have noted down your query. We will be getting in touch with our dispatch counterparts and we will be reverting back to you. Please share your contact details in the chat box. We will be reverting back to you.
Okay, sir.
Sir, I have one question. In case of CR, mechanical properties are required in TC. Our competitor, they have started with TC with all mechanical properties. So यहाँ पे भी सभी customer.
Yes. We had a target to complete our lab facilities by end of this year. Hopefully, next year onward, we shall be able to provide these things what you are asking.
Sir, one more question. एक customer है यहाँ पे जो he used to produce industrial racks. So he's asking CR in YS 250 and TS in 350 MPa with elongation of 25%. So iska I have given him quotation and all, but iska quality extra is very high, sir. I think it comes under ISC 360R. I think that grade only. So any suggestion for this grade, sir?
Okay, we'll see which grade it could be. Separately, we can discuss on that. You please
Or we can suggest that
try to communicate.
any other grade.
You may give that through email. You may let us know. We'll see it. What can be the best.
सर
Through email.
क्वालिटी एक्स्ट्रा में अगर मतलब जैसे CR3 का भी हमारा क्वालिटी एक्स्ट्रा बहुत हाई है, सो कैन इट आल्सो बी मतलब recalibrated?
CR4 it was very high earlier. Now it has been changed. In case of CR4, practically you see what are the issues with customer where it is how the competitor they are giving. In that case, you let us know that separately we should be able to discuss that separately. This quality extra related things, and you must see the customers competitors what they are giving and where it is. So we have solved for CR4. It is. CR4 it was very high earlier. So similarly, we can review wherever it is the cases are there now like this. We can review that.
Sir, I have one more question. I have some customer who is basically taking material from CRM 1 and 2, and they are very cost competitive. And because of this 1,000 rupees cheaper of this old mill material. They are taking only CRM 1 and 2. But nowadays, last few months, I'm getting regularly this rusting and this waviness, all kind of issues, sir. And most of the customers are consumer only. Like MKK, I have already raised. He has given me around 230 ton of more than 250 ton of quality complaint from a single batch.
No,
What
this,
is
this,
it?
these issues has been repeatedly raised through different
Still
platforms,
this,
CFP meeting, customer complaint, customer
no.
CAPA meeting, different forum it has been raised and it has been taken up with sub. They are just like Paisha told in CRM 1-2 also some repairing with CED they have already done. And right now this problem should not
Loading,
come.
sir, such material should not be loaded, no, sir, because it is getting that our brand name spoiled here. Because customer there keep on telling that we have to switch to some other vendor and all like that they are telling. So it is very difficult to sustain such kind of customers. They are consumers.
This material, there could be it may not be see what is happening after inspection. The okay material is going to for the packaging only. And if these are the cases arising during packaging or during transportation, that is not in our hand. That need to be verified whether where is the possibility of getting rust during transportation. As discussion was going on during transportation, also water seepage could be possible. But recently we have changed that packaging pattern. Packaging material it has been changed and corner packaging everything is being taken care.
Old mill and new mill both.
Ideally, what I'm telling now, ideally, there is no rusted material is being, if in inspection, if you found that something like that, it is not being, it is getting diverted to different grade SG, it is being done. It's not that prime grade, it is not given. So it needs to be checked how it is happened.
Yes, sir, this issue has to be taken care of because after getting material and after using it, that complainers regularly it is coming. It's huge.
We are talking about before 1 or 2 months back, na?
Yes, sir.
2 months back, we had discussed already.
Now recently,
So, okay.
Saturday also one coil customer has taken from stockyard, but still he is complaining that same kind of things has come.
Okay, that again the coil yard they have taken means it must be 2 months back coil. So we need to check that some precaution, some prevention precaution method they have taken. Oiling also, better oiling is being carried out. All those things is being done. So you are talking about the previous coils, so that already the corrective action has been taken. Okay.
So I have one last question, sir. Most of the complaints are coming for our this MOU customer for underload.
For
underloading.
For which product, Rakhi?
It is showing wagon carrying capacity is 66 ton and they will be loading like 58 ton, 56 ton, 57, 58 like that the wagon capacity. So they are getting some extra this thing 6 ton, 5 ton ka shortage of this thing freight. They have to pay extra. So such kind of some problems are there. What are the we can do with to remove this such underloading factors, sir?
I think
underloading को कैसे मतलब कम कर सकते हैं सर? underloading का issue customer तो booking he used to give ना जैसे आपका जो pattern है उसी pattern में booking आता है but 58 ton 59 ton अगर load होता है तो how we can remove this क्या we can use some 5 ton 6 ton extra coil for loading और उसके लिए we can give some mail that confirmation mail from customer.
Okay, what you can do, these are the things what you are facing. You may try to communicate the concerned department or they may look into this. On a written, you may provide.
Yes, this thing you can take it up on a written basis because I think RCL, Gadadhar sir is from RCL. So Sahuji, he will not be able to do much. You can take it up formally through an email to the plant, Rakhi. That would be good, the right thing to do.
Already I have taken up with so many. forums web ma'am.
We totally understand your concern, because if this is a customer has to pay that additional freight from his pocket, that doesn't speak good of us, and you must be in an embarrassing position. But I think that you brought it up here. Definitely people from the plant have noted it, and I request Parichay and Nilanshu, both of you can take it up, with your maybe departments where the loading is done, and even PPC could be informed about this, and something could be done. Any more questions before we close? I have shared I shared this screen to share my email and my phone number. Please note, because I'll stop sharing now. This is just, that if you have any suggestions regarding this program or any input that you want to give, you can please connect directly to me. All the presentations of the previous sessions have been put on eAbhigyan. You can search with PACE. You will find this section on PACE, where month-wise I am uploading all the presentations. Other reference material also, if any of you contribute, I will give you credits, and I will upload it there under that year, so that it becomes a good place where we share all the information regarding the product, and it becomes a resource for all our CMO fraternity.
Ma'am, could you please also share the recordings of the
Yes,
sessions?
I will be uploading the recording. Lopa ma'am, you have to share the recording of the previous session. For the first session, Neha, I have uploaded the recording. It was on WebEx. For the previous session of October, Lopa will be sharing the recording with me. I will upload, and for this also I will upload.
Thank
So
you.
that later on also, the people who have missed for some reason or the other, they may be able to. Okay, so we close this now. It has...
एक मिनट मैम प्लीज
Yeah.
मैम वो ECL का कैपेसिटी क्या पूछना था एक बार सर से, ECL लाइन का
हाँ, कौन बताएंगे? कोई anybody from
CR
the...
ECL का वही 30,000 टन्स पर मंथ रेटेड कैपेसिटी है।
30,000 सर। अच्छा सर, आप लोग को ऐसा चाहिए होता है क्या सर? हम लोग का लाइक थिनर में मतलब मैंडेटरी तो नहीं है सर ये, मतलब उससे हमारे को कस्टमर्स को पुश करने से तो मतलब क्या फायदा होगा सर? मतलब
ECL में एडिशनल रियलाइजेशन मिलता है ECL प्रोसेस्ड कॉइल्स के लिए, और टू बी ऑनेस्ट ECL बहुत अंडर यूटिलाइज्ड भी रहता है ड्यू टू लैक ऑफ कॉइल्स प्राइमरीली, तो थोड़ा पुश करने से रियलाइजेशन इंप्रूव करेगा। हम लोग एकदम कर सकते हैं, रादर इट विल हेल्प।
सर जो भी बोल रहे हैं प्लीज अपना वीडियो ऑन कर लें, सो दैट पीपल आर एबल टू अंडरस्टैंड हु स्पीकिंग। या प्लीज। So I think people do have lot of questions. आप लोग separately you can take up questions with me. I will ensure that all our faculty answer those questions, and I will upload it. We need to close now, because I'm sure all of you need to go for lunch also, and then start your afternoon session. Prashant sir, are you there? Or Lopa
नहीं
ma'am?
मैडम, प्रशांत सर एक्चुअली थोड़ा बिजी है।
That's okay, Lopa. It's okay. Then I think ED sir, is he
ED
there?
सर भी नहीं मैडम, ED सर भी नहीं है।
That is okay. Then we close it on our own. Okay.
Okay, madam.
So I want to thank all the participants for your being so interactive, and it is the questions that you ask and the interest that you show that encourages us to make the next episode also. Next month I think one long and one flat will follow that. So probably next month I'll take up some long product. And I would like to thank ED Marketing sir, CGM Marketing, CGM HR L&D, all senior officers of plant and CMO for sparing their time, and all the product executives of CMO for being present here. We have overshot your lunch time also. Special thanks to the faculty for their inputs. It is really nice to see how everyone that I approached, for taking the session, they were very positive that this is a good initiative and they wanted to contribute. So I'm very thankful to Sahuji, Parichay and Nilanshu. Thank you so much. Thank you, Lopa, for being so patient and being here. Thank you, and see you all next month.
Thank you.
Thanks
Thank
all.
you so much.
Have a good day. Happy learning.
Thank you so much, madam.
Goodbye.
Thank you.
Thank you so much.